Yeah. Good morning to all the dignitaries, BAJA SAEINDIA committee members, and all the participating team. This year, BAJA has come up with not one, but two very futuristic categories alongside M and eBAJA. So, taking a step closer to the inception of hBAJA, I welcome you all to today's hBAJA workshop, which is very precisely comprehended to make your design far better. I am Yuvraj Singh Naruka, currently working with Veroc Engineering Limited as a GET. Having experienced BAHA as a participant for 3 years, I am very thrilled to be associated with it as an alumni committee member. Today, I'll be hosting this hBAHA workshop, and I strongly recommend you all to equip yourselves with all the required amenities because today's workshop is going to be very insightful and will surely act as a comprehensive dose, helping you get closer and enlighten your pathway to building of your very first hydrogen BAHA buggy. Let me brief you about the event proceedings now. This hBAHA workshop is divided within 2 days. Today's Today there will be four sessions, which will there will be four sessions of varied topics which you have already seen. After each session, there will be a 15 minutes Q&A session where you can like unmute yourselves and ask your questions, and we'll try 100% to solve the doubts. We'll strictly restrict the Q&A session to 15 minutes. Any doubts after that can be put on BAHA communication. You can mail your doubts as well. This meeting is also being streamed on YouTube. So all the participants who are watching through YouTube Live, you can mention your doubts on like in the stream comments. We'll acknowledge them as well. So adapting to alternative fuel is deeply focused on reducing the overall carbon footprints, and similarly inspired is our concept of hBAHA. To enlighten the route towards zero carbon mobility, we have with us Mr. Ashwin Raj from Mahindra & Mahindra. With over 12 years in alternative fuel technology, Mr. Raj pairs hands-on experience with a bachelor's in mechanical engineering, a master's in automotive engineering from VIT ARAI, and an executive MBA from IIM Kozhikode. His focus on natural gas powered engines and the utilization of biogas for automotive and power generation is exemplified through his 5 patent applications, including one awarded patent. So let's launch today. Let's launch in today's first session. Over to you, Ashwin, sir.
Thank you. Thank you so much, Yuvraj. I hope everyone can hear me, can see me, can hear me. Can you confirm once,
Yes, sir.
somebody?
Yes, sir.
Yes, yes, we can see you and hear you, sir.
Okay, perfect. So with your permission, let me share my screen. I hope you're able to see my screen now.
Yes, sir. Your screen is visible.
Perfect. So before getting into today's topic of discussion, I have given this heading as transition from natural gas to hydrogen while we move towards zero carbon mobility. I just want to take a moment and congratulate each and every one of you who have joined today and who have accepted this unique opportunity of hBAHA, because this is completely new. This is going to be the future. Hydrogen is definitely going to be the future of mobility. That is for sure. And transitioning hydrogen, it is important that we start from natural gas because the gaseous properties are more or less similar, and that is the stepping stone. While almost every manufacturer, if you see, they start from natural gas and proceed towards hydrogen. So before starting my presentation from here on, can any few of you just unmute and tell me what do they know about natural gas, because I can set my like base from where I want to start and what I want to say, something like that. So just like that, what is my natural gas, what pressure it is being used, where it is being used, anything what you know about natural gas, can you just share with me for 2-3 minutes? Anyone from the participant? I hope I'm audible, right?
Yes, sir, you're audible. All the participants, we are here for an interactive session. It will help you gain much more insights. So please,
Yeah, there is nothing wrong or nothing right here. It's just about what you know about natural gas. What is natural gas? Where it is being used? Is it available in your city or not? Anyone having a CNG vehicle at home? Anything can be. At least one, can you volunteer? Someone?
And natural gas is a fossil fuel.
Definitely.
Just naturally looking a mixture of gaseous hydrocarbons
Okay.
and mostly like higher alkanes.
Mm-hmm. Okay. Good.
It
Anyone
has a
else?
low level of like carbon dioxide emission and nitrogen hydrogen sulfides.
Okay. Good. Anyone else?
And availability. Yeah, we have, and one of my friends has CNG car, so.
Uh-huh. Anybody got an opportunity to travel in a CNG car, went to a CNG filling station to refuel your vehicle or something like that sometime? Okay, if there are no responses, can we start? Any one more if you want to add something? Okay, I am still audible, right?
Yes,
I don't hear anything, so I'm not sure that I'm like.
Team, you can like
Yes.
interact. This session is for you, just to like make your experience far more better. Like,
Okay. So natural gas is not something very new. Actually, natural gas is in existence from 1816. You can read about Etienne Lenoir and his hippomobile in the internet. So this was supposed to be the first natural gas driven vehicle which was ever made. And this actually, it was not natural gas though. It was a mixture of CO and hydrogen. It's like a producer gas, similar to producer gas. That time it was called city gas. This vehicle apparently had a thermal efficiency of only 4%. Imagine that days. So this was the first innovation in natural gas recorded in the pages of history. You can go back to YouTube, or you can go back to Wikipedia, anywhere, and you can read about this vehicle and this invention. It is very interesting to read through. So that I leave it to you. Basically, natural gas is methane. Methane is a chemical compound by the formula CH4, chemistry of CH4, one carbon atom and four hydrogen atoms. That's the basic chemistry of natural gas. And it's 90% of this natural gas, when you say as a vehicle fuel, it is methane. Plus, it has a higher hydrocarbons, like one of you just mentioned, it has ethane, propane, butane, etc. And it is a fossil fuel. It is formed deep under rocks, like any other fossil fuel is formed. And the use of natural gas in transportation is also not new. It is in existence from 1930s. But recently, we are seeing a spurt of innovations in natural gas technology. There are a lot of vehicles and a lot of products are coming in. We'll see that in my slides. I don't have too much slides to bore you. I have only 10 or 15 slides. So if you want to ask anything, if you want to have a discussion in between also, I'm open. We can do that. So natural gas is non-toxic, it is colorless, and it is odorless. You might be knowing that the LPG which you use in your home is also basically the gas is odorless. The odor comes from a substance called mercaptan, which is added to these gases to give it that pungent smell, so that when it leaks, you know that it is getting leaked. So that is why these gases have a smell. What we basically have to understand is natural gas as a basic organic substance, CH4, is odorless. It is lighter than air. It has very low density, unlike LPG. So LPG is denser than air. So when there is an event of an LPG leak, what happens is that the gas stays where it is getting leaked. So if it is getting leaked slightly in your kitchen or something, the gas stays there. So that is why people say that once you have an LPG leak or something, you should not switch on your lights or anything which can lead to a spark. And you have to open your windows and doors to allow the gas to escape. But natural gas is not like that. Natural gas is comparatively safe, because natural gas leak is not as risky as LPG leak, because it is lighter than air. So it quickly dissipates into the upper atmosphere. So it doesn't stay where it is getting leaked. So in that respect, natural gas is safe as a fuel. So if you have a thought process in back of your mind that natural gas is very risky, it is unsafe, it will catch fire soon, it is not right. So natural gas is comparatively safer than your LPG. That is what you have to understand first. But there are some other aspect of it which we'll see in this presentation. It has a combustion limit of 5 to 15%. This combustion limit means you need to have at least 5% to 15% of natural gas mixed with air, 15% of natural gas with air, or 5% of natural gas with air. In this band, it will burn. Below that, below 5% natural gas is there in the air means it cannot catch fire. Above 15% also it cannot catch fire. And this is one of the major thing which you have to keep in your mind when you proceed towards hydrogen from natural gas, because this one property of hydrogen is very unique, which I'll cover in my last slide today. And that will be the major point of safety aspect when you look it from the hydrogen perspective, not from the natural gas perspective. So for natural gas, the combustion limit is between 5 to 15%, and it has an octane number of 120. Can someone of you tell, because I just want to ensure that you are all connected, what is the octane number for gasoline in India? I'm still connected, right?
Yes, you are connected.
Okay. Hello? I couldn't hear.
Yes, sir, you are connected. You are audible.
Okay. Thank you. So today we have 93 octane petrol, something like that, and we have a higher octane of 95 also available. Natural gas is around 120, the octane number. So the anti-knock index is high. So you can use a higher compression ratio than gasoline. Gasoline compression ratio is around 10, 9 to 10 approximately, usually what is used. But for natural gas, the best possible compression ratio which you can go for is around 12:1. I don't have that detailed in the slide. Those things will be covered in the engine presentation probably. But this is what you can keep in mind. The natural gas combustion ratio will be around 12:1. Why there is a spurt of natural gas vehicles in the market recently is because of government intervention preliminary. It is predicted that by around financial year 26, we'll have around 10,000 fueling stations in India. As per 22 data, what I've got, around 4,784 stations are there. And yesterday, when I was reading through, I saw that this number has gone close to 5,200 today. And the CNG market share in India has grown up to 10% in 22 compared to 0.1% in financial year 16. That is, in 7 years, it has gone from almost none to around 10% of vehicle sales is now natural gas. In passenger vehicle segment alone, in the entry level segment, you can see that the year-on-year growth ratio is 40% in financial year last year. So that is very significant. So most of the OEMs are started investing in natural gas vehicles development now. On the right-hand side, you can see how the CNG stations are dispersed across India. We have around close to 1,000 stations in Gujarat and around 2 in Assam. That is the lowest which I could see. This data are collected from the internet. So if you have anything, which you see that anything is not right, please let me know so that I can correct my slides. Somebody just pointed out that it has lower carbon dioxide emission. It is 20 to 30% lesser than diesel. That primarily because natural gas has lower carbon to hydrogen ratio. It has 1 carbon atom only to 4 hydrogen atoms. That is the reason why you get lower CO2 compared to gasoline, not diesel. Sorry, because diesel is a lean burn engine. You cannot compare that way. And approximately across India, if you see the CNG natural gas prices are around 5 to 8 rupees lower than diesel, and it gives the same efficiency of diesel. So you get a better operating advantage. That is why the natural gas vehicles are being sold in the market, or there is a market pull for natural gas vehicles. Throughout India, if you see nowadays, now you can see that the natural gas availability is spread across the country. On the left-hand side is the map from Ministry of Petroleum and Natural Gas, where they have put the details of where the CNG pipelines are laid out, where CNG is available, and where CNG is expanding and other things. Right-hand side, I just tried to put the same slide in another format, in the map format, so that you can see in which all states natural gas is currently available. I couldn't find any particular data about Chhattisgarh here. So if you have any information, please let me know so that I can update. So almost in all other states, I can find that natural gas stations are currently available. In terms of product portfolio, natural gas vehicles are being used in the PV segment, in the CV segment, in the genset market, and this is not the end of the story. The natural gas vehicle portfolio is being expanded, and it is going to tractors and off-highway equipment vehicles also. You can see that New Holland has recently launched a CNG powered tractor in the US market in this February, and they are available in the European market also. In India, we had a CNG powered tractor launch by the ministry around, I think, last year, May or June, something like that. And this company, JCB, had also introduced a dual fuel diesel CNG loader, backhaul loader in the Indian market. So natural gas is finding other avenues of growth. So that is one of the important aspect which is happening around you. Some of the very key important properties of natural gas. I can put a slew of other properties here, but I have tried to concentrate and put a number like four very important properties for you from your perspective of this hBAJA. It is the first one is the calorific value. The calorific value of natural gas is close to 55 megajoules. For gasoline, it is 47, and diesel, it is 44. So what you want to understand from this fact is that natural gas has higher energy content than gasoline and diesel. It is not an inferior fuel. It's actually a superior fuel in terms of energy density. Sorry, not energy density, energy capacity compared to gasoline and diesel. It has a minimum ignition energy of natural gas around 540. For gasoline, it is around 246 to 280. For diesel, it is around 210. Which means that if you want to ignite natural gas, you need to bring it up to a temperature of 540 degrees centigrade. That is very important. So you cannot use the same spark plug as gasoline. You will need to use a high energy spark plug for CNG ignition. That is one aspect or one takeaway from this property. So the ignition energy of natural gas is very high. The stoichiometric air fuel ratio of natural gas is 17.2. For the gasoline and diesel, it is around 14.7, 14.5, which means that you will have more air to fuel in the mixture. And that ratio of stoichiometry you have to maintain during combustion for a stable natural gas combustion. So that is one more factor. And the octane number, as we have already discussed, it is higher than gasoline and diesel. So it has a better anti-knock property, and you can use a higher combustion ratio than gasoline. So if you have any doubt on this slide, we can discuss now before going forward. Anything?
Yes, sir.
Tell me.
Sir, yes, sir. When we go for CNG, that performance-wise means that efficiency-wise it is increased, but performance-wise it is get reduced because torque and power in the case of CNG is reduced by 10%, right? So
see, this is to be understood well because when you say that when you go to CNG, your performance is getting reduced is from your personal experience?
no, sir, I did analysis.
Okay. So the thing is that when you are using a petrol engine, a gasoline engine, okay, and the gasoline vehicle take the vehicle as a whole. The gasoline vehicle you want to convert to CNG, okay.
Right.
Gasoline has a lower octane number you see in this slide. So gasoline has a lower combustion ratio. When you use natural gas in that particular engine, okay, you will get a lower thermal efficiency. It is like you can use 12 combustion ratio, but you are able to use only 9 combustion ratio, right?
Yes,
so there's an efficiency drop there because you are not utilizing the property of natural gas there. That is one part. Second part is that you have CNG tanks on the vehicle, right? The CNG tanks are heavier.
Yes,
so the power to weight ratio will slightly go down.
Yes, right.
So in that aspect also the vehicle performance will slightly drop, and that is why you see that in CNG vehicles there's a performance drop compared to gasoline. But if you take a diesel engine or you dedicatedly try and develop a natural gas engine, it can be higher efficient than a gasoline engine in practical.
Yes.
Okay, clear?
So means so we have to change compression ratio accordingly, right?
Ideally, when you're doing a dedicated natural gas engine development, you have to do that. Okay.
Yes.
But usually that is not the market practice.
In the case of bifuel engine.
It's a bifuel engine. Most of it is bifuel engine. That is why we don't do that, because you want that fuel flexibility.
Yes, sir. But means in case of BSFC that
Hmm.
it is reduced means that what we say
CNG will
mileage is
give you a
increased
better
in the
result
case
than gasoline,
CNG.
definitely.
CNG.
Yes, CNG will give you
Yes.
the better result because of the calorific value.
Okay, sir. Thank you, sir.
Okay, thank you.
Yes.
So these are some jargons which you will come across during your working on this hBAJA probably. I just want to clear your mind on all these jargons. So if you have any doubt on this jargon, let me know. NG is natural gas, as we discussed. CNG is compressed natural gas. It is only that this natural gas is compressed and stored in cylinder like this. This is the CNG cylinder, what you see here. CBG is compressed biogas, which is your basically biogas produced, purified, and compressed to CNG pressure, which is 200 bar. LNG is liquefied natural gas, where this same CNG, instead of compressing it, you liquefy it at minus 162 degrees centigrade and store it in a cryogenic tank. That is called LNG. PNG is piped natural gas, where the natural gas is compressed to only just above atmospheric pressure and pumped through pipelines. This you must have seen in Delhi NCR region and other region where you have natural gas pipeline. You can see this gas pipeline is going below. HCNG is hydrogen enriched CNG, which ideally the ratio is around 18%, where you won't get any changes from CNG. So this is hydrogen enriched CNG. And LPG, what you have at home, is completely different. That is liquefied petroleum gas. It is a mixture of butane and pentane. It has nothing to do with methane, and that is completely different. Don't confuse between LPG and CNG at any time. That's a big mistake. Another very important jargon is the concept of monofuel, bifuel, and dual fuel vehicles, which our friend had just asked about bifuel. So I just want to clear your mind on all these three concepts. This is very, very important. Whenever you are telling, like, some vehicles are called duo in the market, they are not dual fuel vehicles, they are bifuel vehicles. So when you are telling about a monofuel vehicle, like I just told you, monofuel vehicles can run only on one fuel. It could be any fuel, it could be CNG, it could be petrol, diesel, anything, but it can run only on one particular fuel. And this term, particularly monofuel CNG, is used for natural gas vehicles. That is why monofuel CNG we say. So this vehicle can run only on CNG. It cannot run on any other fuel. And the engine is developed and optimized for CNG usage. It gives very good efficiency. But the problem is that it can run only on CNG. For the CNG is over means you have to go to CNG station and refill it. You don't have any other options, or you have to tow it. And so it is possible to use this kinds of vehicle only where in cities where CNG is available. Otherwise, you cannot practically use these vehicles. That is the limitation of a monofuel vehicle. And bifuel vehicles are vehicles which can run on either gasoline or CNG. What you need to understand in the basic concept of biofuel is that both these fuels are from the same category. Both are SI engine fuels only. Okay. The limitation is that you can operate only on gasoline combustion ratio, because if you shift it to CNG combustion ratio, when you use petrol again, there will be knocking and engine failure. So you cannot do that. You can operate only on gasoline combustion ratio and use CNG in a kind of a compromising mode. So that the problem is that you will get lower efficiency than a monofuel vehicle in a bifuel vehicle. On the other hand, you will get fuel flexibility. So if you don't have CNG, you can go and fill petrol and use. And these two fuels are controlled by a switch. You either select CNG or select petrol. Like that, you can use this vehicle. And these vehicles are called bifuel vehicles, which is very important. You have two different tanks on the vehicle, storing two different fuels from the same category, which can be selected by using a selection switch. That is the definition of bifuel. Okay. Dual fuel is a different concept. Dual fuel, you have a primary fuel and a secondary fuel. Primary fuel is usually a combust ignition fuel like diesel or DME or something like that. So this is your primary fuel, and natural gas, hydrogen, LPG, anything can be your secondary fuel. So it's usually an add-on kit. The CNG kit is added on the diesel vehicle. You are operating at a very high combustion ratio, like diesel combustion ratio of 19, but you are using a very lean mixture. You are only adding very little bit of natural gas, not enough to create any kind of knocking in the engine. Okay. it has very low operating expenses because CNG is cheaper than diesel. You are replacing some part of diesel by CNG. So basically what happens in a dual fuel vehicle is that when the air is coming inside the engine, in the intake air, you inject some amount of CNG. So the air fuel mixture will go inside and you reduce the amount of diesel injected directly into the combustion chamber. So the totality, if you take a summation of energy, the energy content will remain the same, but only some part of diesel will be replaced by CNG, and this will be used for combustion. And this is a fuel flexibility. Fuel flexibility in the sense, if you don't have a CNG on board, you can still run on diesel. But if your diesel is empty, you cannot run on CNG. You have to always have the primary fuel for combustion to happen. The diesel will ignite, and that ignition energy is what will lead to the combustion of CNG. That is the principle of a dual fuel engine. So in a dual fuel engine, ideally 50 to 60, maybe around 70% of your primary fuel can be replaced by a secondary fuel. So once again, it has two tanks storing two different fuels, two different category of fuels. One is a primary fuel, one is a secondary fuel. And always you can use only with the primary fuel. You can either run on 100% primary fuel or on a mixture of primary and secondary fuel. That is a concept of dual fuel. Any doubt on this slide? Let us clear it now. Hello?
No doubt, sir, no doubt.
Okay.
Sir,
Yes.
sir, in the
Sir,
previous slide, you mentioned that CBG and CNG. Sir. Let me take the previous slide. What makes the major difference of the CBG with the CNG? Can
See,
we run any
biogas,
vehicle with the...
yeah, see this biogas, when you produce it from your any like biodegradable source, you can generate biogas. Biogas has around 50 to 60% of methane, okay, and rest of it is majorly CO2. Then other components are also there, like some water vapor is there, some other substances are there. So what we actually do, do two things. One is a scrubbing process where you remove all other impurities of in the biogas, and then you lead it to a purification process. In the purification process, to explain it to you very simply, it's like a big soda maker. So what you pass it through a high compressed vertical vessel, and in that you spray water from the top. The CO2 will dilute in the water and come down, and the gas, the methane will flow up, and this methane will be captured, dried, and compressed. So it is still 90% methane plus around 5 to 10 percentage of CO2. The difference between CNG and CBG is that in CNG, you have higher hydrocarbons other than methane in the composition, basic composition. But in CBG, you have CO2 in the basic composition. Both are methane technically. Okay. But you cannot call biogas as CBG. When you use the term CBG, it is purified and compressed biogas. It can be used in vehicle like CNG itself. There is no problem. It is actually better.
Okay, sir. Thank you.
Okay. Thank you. This is clear, right? Can we go forward?
Yes, sir. So in this
Another
slide, that in dual fuel engine, that third point is diesel compression ratio means. Can you elaborate?
You don't change the diesel compression ratio because diesel have to burn, no?
Okay. Yes, sir.
But the CNG quantity will be very, very, very less. It will not be in stoichiometry.
Okay. Okay. Thank you, sir.
Okay. Another very important and very confusing concept for you today is energy density. This you need to understand. This you will come across in your BAJA definitely. Okay. So if you take 1 liter diesel tank, imagine you have 1 liter diesel tank, and you compute the total energy content in that tank. If you want to store the same amount of energy content of CNG, you need 5 such tanks at 200 bar. Understood? Any doubt why it is so?
Pardon, sir. What you say? Pardon, please. Sir.
Yeah, if you have some amount of energy stored in 1 liter diesel fuel, imagine, right? Okay, if you want the same amount of energy in CNG, you need to have 5 tanks this capacity multiplied by 5 at 200 bar pressure, because CNG is still a gas.
Okay.
Okay, it doesn't have density.
Yes. Yes. Right.
For that reason, you need to have 5 times this volume to store the same amount of energy, and that is a major challenge of CNG vehicle also. You need a lot of
Yes.
storage space on board.
Yes. Yes.
It has more energy per kg, but per cubic meter it has very low energy. That is what the meaning is basically.
Yes, sir. Yes.
Clear, no?
Yes, sir.
If you want to store it as LNG, if you want to liquefy it, you need 1.8 times the volume of CNG diesel tank. Okay, and it has to be stored at minus 162 degrees centigrade in a cryogenic tank. So that is about LNG. And there are 4 different types of cylinders to store CNG. This you need to understand. This you will come across. You have a type 1 cylinder, which is a traditional steel cylinder. Type 2, which is a composite cylinder with reinforcement. Type 3 is with a metal liner composite cylinder. Type 4 is a composite cylinder with polymer liner. The technicality you need not to understand, but you need to understand is that as you go from type 4, now type 5 is also there. As you go from type 1 to type 5, the weight of the cylinder reduces so that your vehicle weight can come down, but the cost increases in manifold. Okay. Mostly all of these applications we are using type 1 only. So you will also encounter with type 1 cylinders only mostly. The different ways in which CNG tank can be packaged on vehicles are shown in this slide. It can be below your vehicle. It can be packaged on one side, below again. On your rear dicky volume, you can package the cylinders. It's an integrated packaging where you develop the packaging with the vehicle so that you don't have to compromise on space. There, this one you can see. On buses, you can package on the top or bottom. So these are different approaches by which you can package the cylinder. I just want to show you and give you an idea that which direction, but most of it's are horizontal. There is a standard called AS024 and 028. Tomorrow there is a session, I think, on the standards in detail. This is very important, and this gives you all the detail about how to package CNG system on board the vehicle. The high pressure system, the low pressure system, the tanks, the valves, etc. Where, which, how much distance, how much force you need to use to pack that, and what are the minimum clearances required. Everything is covered in the standard. And tomorrow, I think Rarikar sir will cover in detail about all the standards. And this is probably my last but one slide. This is the CNG system, which you will see in your vehicle also in hBAJA. Pay attention to me very closely in this slide. This is the most important slide for you today. So you have CNG cylinders which stores gas at 200. The cylinder need to have a tank valve. This is called a tank valve. In the today's presentation of the CNG kit, you will learn in detail about tank valve, how to mount the tank valve, etc. Probably. So this tank valve is used on the CNG cylinder. The tank valve, until you have the pressure regulator here, this is pressure regulator. There is a coming. Okay. So is only steel. You coming across carbon steel only, but it has to be pipe approved for this application and usage as per AS028 and 024. Okay. Then in the cylinder, you need a pressure gauge. Okay. You have a refilling valve here. This refilling valve either could be, if you're having one cylinder, this tank valve and refilling valve can come integrated also as one thing. Okay, with the pressure gauge. This 3 things can be integrated into one. That is also possible. So you have a refilling valve. When you fill the gas for tank, okay, then you have a high pressure filter. Not mandatorily used in every application, but it is recommended to use a high pressure filter mostly in all production application. But I don't know whether you will use filter or not. But you can have a HP filter here, which will filter any sort of impurities in the gas. If you can ask me, somebody can ask me, oh, how does impurity get into this gas? Where does impurity come in gas? I can understand in terms of liquid, but where in gas? The impurity comes in the combustion process mostly. When you compress this gas to 200 bar in the combustion stations, some amount of impurity and oil particles can get into the gas from the compressor. So that is why you have to use a HP filter. From the HP filter, it goes to a pressure regulator. Pressure regulator is different from a valve. It is not a valve. Whatever input pressure you give it here, it will give a fixed output pressure. That is the important function of our pressure regulator. So you have 200 bar coming till here. From here, you have only 5. This uses a 5 to 6 bar system. It could be 2 to 3 bar system, 1 to 2 bar system. Based on whatever system you are going to use in your vehicle, this output pressure will change. But here I just have given an example of a 5 to 6 bar system. Again, to protect your injectors, you have a low pressure filter. From low pressure filter, it goes to the injector in the throttle body. Mostly it is TBI only, throttle body injection only. From there, it gets into the intake manifold and goes into the cylinder. And you have the CNG engine, and the engine will be running on that. So this is the basic CNG system layout. It is split into two. One is a high pressure system, high pressure side, and the low pressure side. On the high pressure side, you have every component until the pressure regulator. After the regulator, we have a low pressure side. Also to the regulator, usually we circulate water through the engine coolant is circulated through the regulator. Because, can anybody say why? This is basic physics only, nothing more than that. Can anybody guess why we are circulating water through the regulator?
Sudden change of the pressure can cause the temperature difference.
Yeah, exactly. Brilliant. You have a sudden pressure drop happening here, so it will chill. It can form ice in some conditions. To prevent that, we circulate water through the regulator. So you have a coolant out circuit given, but this is not very mandatory if you have a limited application scope. But when you are doing a proper production application scope, it is recommended and you must do that. There is no other go. So I hope this is understood. This is what you have to do basically on the vehicle. This is what all these components you will come across today in very depth, very deep. How does a regulator work? What is the output? All these details you will come across today. So I think this slide is understood, means my purpose of today is served.
Sir,
Can
I
you go
have one more
forward?
doubt. So we are sending the water from the radiator, or we will make a separate thing for that.
From the radiator in out, we usually circulate. See, anyway, you can do that. That is up to you. But only thing is that you have to ensure that the circulation is there. As per mounting recommendations, the regulator should be below the radiator top side. Okay, if you're doing this. Otherwise, the water won't circulate. That is it.
There is a question in the chat box. What is the use of LP hose?
LP hose. Okay, sorry. LP hose after the regulator, you have a low pressure system, right? Still, the gas has to go into the injector. So for that, use a hose. This hose can withstand only up to 10 bar pressure, not more than that. But in HP side, you use a system which can withstand up to 250, but you use only up to 200. Clear? So this is also approved hoses by ARA as per AA standards. So that only you have to use. You cannot put any, don't put water hoses there, it will burst. Clear? Can you go forward?
Yes, sir. Yes. Sir, you said that we have to put that means regulating for regulation of water that above radiator, right?
Below.
Below okay, below radiator.
Not below radiator, below the radiator top.
Below the radiator top. We don't have to use motor for that, like for that only.
Which one? You have to ensure that water is circulating through the regulator for that purpose only.
Naturally, right?
Not naturally. You have an engine pump, right? Coolant pump in the engine, right?
Right.
So it will be circulating water. So from the high pressure side of the pump, you take a tapping and give it to the regulator. Outside, you return it to the radiator out. Simple.
Okay.
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 I don't know whether you'll be using that or not, but you can check it. You can check the feasibility in your vehicle and all those things. But In production, generally, when you have use everywhere across the country in different regions and all, this is recommended.
Okay, sir.
My last slide for today, I wanted to give you a heads up on hydrogen because finally it is called hBAJA. So hydrogen has a calorific value which is more than double that of CNG. Okay, it is 120 megajoules per kg compared to 55 megajoules per kg for CNG. And the most riskier aspect of hydrogen is the next one. It has a minimum ignition energy almost 1/10 of CNG. CNG has an ignition energy of 0.1 millijoules and hydrogen has an ignition energy of 0.019 millijoules. That is almost 1/10 of CNG. So if you have little bit amount of hydrogen in the air also and some sorts of fire, it can catch fire. Very risky. The combustion range for CNG is around 5 to 15%. But for hydrogen, I told you in the beginning also, this will come later in my slide. It is around 4 to 74% and 4 to 94% if you are having pure oxygen around. Okay. So if there is little bit amount of hydrogen in the air or it is too dense also, doesn't matter. It can catch fire. Hydrogen stoichiometric ratio is 17 point, CNG is 17.2 and hydrogen is 34. It is almost double. And operating mode in hydrogen is very lean compared to CNG of stoichiometry. So you can get very high efficiency, fuel efficiency when you are using hydrogen engines, but you have to take care of the safety aspects very seriously because of these particular parameters, properties of the fuel. Okay. So that is what I wanted to give you as a message today. And that will be your future teams will be next year or next to next year, people will be doing this. So currently almost in every company, I think none of the hydrogen engines are into serial production today, even though some JCB has done a batch production or something like that. But most of the OEMs are in active research on hydrogen engine development. So if you see the key challenges of running the engine on hydrogen, it is the knock tendency. Hydrogen will knock very fast. It can see any kind of hotspot within the combustion chamber, the hydrogen can catch fire and it can knock. That is what is called a hydrogen knock. It has a very high knock tendency. It has a very low density, around only 1/3 of CNG. Imagine CNG itself has a lower density, but hydrogen has 1/3 of the density of CNG. So what happens is that if you inject hydrogen in the intake side, it will displace a lot of air because it needs space to expand. So when that happens, your volumetric efficiency goes down significantly. And for the same reason, at low RPM, first of all, you're operating lean. You have higher low density fuel on board. So your low end torque, at lower RPM, the torque output on a hydrogen engine will be very limited. And you need to use some sort of supercharging or turbocharging mechanism to enhance the airflow to get the required amount of torque in a hydrogen engine. It has very high flammability limits. Little bit amount of hydrogen in air also can catch fire. So hydrogen vehicles, you will see that a hydrogen leak sensor is mounted in some positions. So to identify if there is a leak, the hydrogen fuel supply will be cut off in the vehicle. So for the safety aspect, that will be done in hydrogen vehicles. In CNG, we don't have that. We only have a vent pipe because the combustion range is very minimum. Developing an engine oil for hydrogen is also challenging because in the combustion output, you have mostly water vapor. And this water vapor will go into the crankcase, it will dilute the oil, engine oil. And so developing an oil which has low absorbency of water and all that, it is very challenging. It has a very high backfire and flame quenching distance. Flame quenching distance means hydrogen flame can travel very close to the surface, like the combustion surface, the valve surface, etc. So when during the hydrogen combustion, if you have hydrogen in the intake side, maybe if you're using a throttle body injection sort of thing, you have hydrogen in the intake. And while your valve is opening, if there is flame inside the combustion chamber, it can travel back into the intake side and it can burn there. That is called backfire. So that can happen in terms of hydrogen engine. So currently all OEMs are in the process of developing solutions for all these technical challenges what I have presented here. So that is actively happening in hydrogen in the industry, while today our concentration is on CNG. Yes, that is it from my side. Any doubts you can ask. We take 5 minutes extra maybe.
Okay, teams, like you may ask your questions, any questions which you have. Like usually in your daily life, you won't come across such an experienced professionals. So when BAJA brings you this opportunity, try exhausting even the last bit of droplet of knowledge you can from them. Mr. Ashwin sir is looking forward to answering each and every question. So please go ahead. Or don't shy. You can even like if your internet connection is unstable, you can put it in the chat box or like directly unmute your mic and ask the questions. Please teams, go ahead. And like if you don't have any questions, just let me know in the comment section, like in the chat box.
Good morning, Ashwin. I'm Kaleem from Greaves Cotton, Aurangabad. Just going through your presentation. One of the excellent presentation, very informative, and thank you for. It's a good learning for us also.
Thank you, sir. Thank you so much.
Yeah. Very good.
The teams do you have any questions? If not, we can move on with the next session. Okay, I presume you're okay. Okay, sir, there's a question. How to select tank and the dimensions?
I think that will come in your later presentation, right? In detail. The
Just
tank dimensions and all those things.
Okay,
One thing I can give you as an input is these are approved tanks. There is not much of an option where you can decide on what tank size you want to. From the list of what is available as approved, you can select what is possible.
Okay, so I presume that all the doubts of the teams have been cleared by a very insightful presentation. Thank you, Ashwin sir, for your insightful and factful session. Your session was truly helpful for the teams in expanding the knowledge about the natural gas and the fuel for propulsion, along with its basic layout. So thanks a lot, sir, for being with us.
Thank you. Thank you so much.
Thank you, Mr. Ashwinji. This is Piyush Balia from Atuloto Limited, and I am looking after the research and development. It was a very fantastic information shared by you.
Thank you.
I would like to know, can we get the same presentation so I can share with my downline and they can also upgrade their knowledge?
We'll see. That should not be a problem.
Okay. Thank you, Ashwinji.
Thank you so much. Thank you.
Yeah, Yuvraj, just a minute. Ashwin, thank you for the presentation. And
thank you, sir.
We request you to stay in the session as other speakers are also there. And yeah, if
so you may stop the presentation now.
Shall I start my presentation?
Is the slide visible?
Yeah.
Yes, now visible.
Okay.
So moving on towards the next topic, we have Dr. Kalimuddin Said from Greaves Technology Center to illuminate upon the CNG biofuel engine and the very important control systems. Dr. Said has completed his bachelor's in mechanical engineering from College of Engineering Aurangabad, master's in mechanical engineering from Regional Engineering College Warangal, and has earned his PhD from NIT Warangal. Mr. Said, General Manager at Greaves Technology Centers, has over 25 years of experience in currently leading the diesel and alternative fuel engine development programs for BS6 and Euro 6 automotive applications. So without any delay, let's begin. Over to you, sir.
Yeah, thank you, Yuvraj, for a small introduction. I'll just go directly to my presentation.
Yes, sir.
Hope slide is available on the screen.
Yes, sir, it is visible.
Yeah, so good morning, everybody. Just a
Sir,
minute.
very good morning.
Yeah, good morning. So today's topic is on the engine, what we are going to give for hBAJA. That is G400WG BS6 CNG bifuel engine and its control system. And mostly I'll be focusing on the hBAJA requirement for this engine because the students will be doing this project on the same engine. So the contents will be engine specification, engine performance, engine nomenclature, engine sensor layouts, sensors and actuators, engine lubrication systems, engine cooling systems, engine OMS, that is oil mist separators, how it is been there, engine charging system, engine exhaust system, then engine CNG systems layout, engine gasoline system layout, engine layouts and its accessories and tightening torque and service. So I hope everything will be covered in this presentation for your requirement of hBAJA vehicle or what you call it. Into the specification, it's already shared earlier also. This engine is 400cc engine, water cooled, 4-stroke, and ignition operated, that is spark ignition engine with 1 cylinder. 396cc, having a power of 7.25 kilowatt with maximum torque of 23. Drive weight is 46, oil capacity 1.62 with spin-on filter, and oil capacity without spin filter will be 1.4 liter. And I'll go to next slide. It is a water-cooled engine, so it is operated by a centrifugal water pump having a thermostat fitted. It will come as a loose also, or we can fit it. So operate at 72 degree and it fully gets open at 80 degrees centigrade. Recommended is 15W50 API. Then it's having a starter system with electric starter motor. That is having a charging system of FMA. Its low idle speed is 1200, high idle is 4000 RPM. Then other is related to the coolant that will go in detail. The basic engine performance curve wherein you will get maximum power at 3600 RPM and max torque at 2200 RPM with best BSFC around 22 to 2600 RPM. This is basic port-to-port dimension. This is important for your packaging point of view. Having a length of 330 millimeters and width of 358 millimeters and height of 485 millimeters. When the gearbox is packaged, you have a room of 300 millimeters on your vehicle. Then the distance between the fit where you want to bolt it is around 266 millimeters. So these details will be shared to you, and I think it will be already shared. So based on packaging point of view, you have to take care about this. To have a proper packaging point of view, having a clearance between your chassis members, cylinders, and the seating arrangement. And this engine can be mounted as in front also, and this engine is mounted on the rear also on the three-wheeler application. So it depends on the students how they are going to package this engine on their buggy. Coming to the basic nomenclature, it's having, if you go through the basic photograph or the model of this engine, it is packaged with HT cable injector, that is CNG injector on the manifold, oil mist separators, then carburetor will be there, then spark plug definitely because it's spark ignition engine. Then ignition coil is also fitted on the engine itself. Starter motor is also on the engine itself, fitted on the starter plate. Then flywheel, that is with magneto. Oil peel will be at the beneath. Then a rocker cover, it is a closed loop rocker cover, so no oil spilling, everything will be observed. Oil filling cap will be on the top. You have to fill the oil from the top of the rocker cover. Then oil level gauge, dipstick is there, you can see. Then oxygen sensor is there on the fitted on the manifold. Then cylinder head, catcon assembly, water pump assembly, then crankcase, then pulsar coils, that is to detect TDC of it. Then water pump for the circulation and water pulley for the circulation of water. This is the basic nomenclature. When engine will come, definitely we're going to give the training to the students also. This is an informative slide for you. What engine hardware will be equipped with. Coming to the sensors, it will be fitted with the CNG filter, ignition coil, T-map sensor, coolant temperature sensor. These are an oil pressure sensors. These are some preliminary sensors. Apart from there, few more sensor will be there. That is oxygen sensor, then pulsar, FMA, throttle position sensor on carburetor. So everything will be fitted on the engine. So student had nothing to do with it. Only if in case if anything malfunctions, you have to do service out of it. Coming to the sensors, this is the T-map sensor. It is used to measure temperature and pressure of the intake manifold. Then oxygen sensor is used to measure oxygen air fuel mixture. I think Ashwin sir has taken in detail about all this functioning in his previous slide, and I think Advantic will also explain all the details in their slides. I'll not go in deep. Idle control valve is used to control idling air for engine. Then ignition coil transformer, low voltage to high voltage for spark plug application. So all these are on the engine, fitted on the engine. Then injector on the intake manifold, which is driven by ECU to inject CNG in manifold. Then rail pressure sensor, working pressure is almost 1.5 to 4.5 bar. Then it comes to carburetor. I've already told it is with a TPS sensor fitted on the itself to find out based on the throttle demand of the driver at to what throttle it should work. Then temperature sensor, it is used to monitor the engine out coolant temperature. This is an engine lubrication circuit diagram. It is just for information that if you see, it is a very simple single cylinder engine used for your buggy application. Engine is sucked from the oil pan, goes to the pump, lube oil pump. It will go to the spin-on filter, and spin-on filter will again push the filtered oil into the crankshaft journals and the bearings and the mist lubrication on the piston top side. So very simple mechanism. It is only for informative. Again, student, just to know, it will not be useful for you, but you should know how this lubrication system of the engine works. Coming to the engine cooling circuit, it is having a small radiator. This is fitted on the vehicle actually. It is not on the engine. So this will be a scope of, I think Atul Auto is going to supply you for this. And it consists of a small radiator having a heat dissipation of 6,500 kilocalories per kg. So circuit diagram is simple. Engine, hot water or hot coolant will go to the radiator and it will again pull in through the pump on the engine side. It will have a pressure cap, temperature switch, coolant outlet from front, water pump, then degassing hoses. These are all in the scope of Atul Auto. They will provide you all this. Then degassing tank, electric fan, then coolant. So it is simple. It is not a complex like four-wheeler where this air conditioning unit is also attached to this. It is simple three-wheeler application-based circuit. This is the recommended radiator. Mostly SM Auto is one of the supplier of the radiator, which is a very compact one, and you can use it having a heating capacity of 6,500 kilocalories per hour. And it holds a water capacity of 1 liter only. So not much of water will be consumed here. And it operates, I think watt power is important here. It consumes 130 watts power. So you have to see the battery capacity, selection of the battery capacity and other things for this requirement. Coming to the engine cooling system layout on the vehicle, it is usually remote mounted. It is not necessary that it should be in the front of the engine. It can be parallel to the engines also. When the hoses and everything can be mounted in such a way that it should not intersect or foul with the engine rotating parts. You can see from the front of the vehicle, then it is fitted to the left side of the vehicle, and remotely fitted engine is in the center point of view. Coming to the bypass, there is a whatever the pressure is developed that can be bypassed into the pump. So no need of any auxiliary system to control the bypass of the thermostat water flow from the engine. This is the OMS circuit, that is oil mist separator. Whatever the oil should be there, it should be drained to the oil pump oil sump, and gases to be put in the intake manifold. You can see this black pipe. This is the gases will go to the air intake side and it will burn again. And all the oil and other thing will be filtered in the OMS, and it will go and drain to the oil pan, and it will filter almost 99.9% of oil from the gases. Coming to the charging system of the engine, it's having a FMA mounted on the flywheel itself, and it can generate of 36 amps current at say 3600 or 3800 of high idling RPM, and minimum of 15 amps current, which suffice the requirement for three-wheeler requirement. It's having a small electrical circuit, wherein the circuit will be available in the vehicle wiring harness, which will be provided by Atul Auto to you for this application. This is the simple schematic or the photographs for the charging system, how it is there. Flywheel is there. This stator will be fitted in the magneto. There is a magneto in the flywheel where flywheel will rotate, and the current will be generated, AC current, and this AC current will be converted to DC with the help of this RR unit. This will be in our scope. We are going to supply as accessories along with the engine. Coming to the engine exhaust system, it's having an oxygen sensor, then exhaust manifold, then catalytic converter. But this is usually suitable for three-wheeler application. This you need to modify it based on your packaging point of view on your buggy. What I suggest, this will not come in our scope, or it's not required from our side. You have to design it properly based on your vehicle application so that it can be packaged and routed properly on the engine and the vehicle. Coming to the belt tensioner and other thing, this you need not to take care, because it will be tightened at our end. It is self-adjusted belt. It is been done during engine testing at our end itself. It is having a 3 PK belt, self-adjusted. Very simple mechanism. After once it is tightened, it never loses for almost 1 lakh kilometers. That is the advantage we got with this. Coming to the CNG fuel injection system layout. I think Ashwin sir has already explained you all the CNG system, how it is functioning on the three-wheeler, on the vehicle. But whatever I am explaining is only for three-wheeler application. So what I feel you adopt is a similar way. It is a simple, usually from CNG tank to CNG tank wall will be assembled on the tank itself. Then it will go to HP line, then CNG regulator, then LP line, then CNG filter and injector. Very simple layout can be fitted on your buggy. This is one of the schematic, what is available on the three-wheeler application. This cylinder, I think it is around 4 or 5 kg gas cylinder we are using. And we used to call it 40 or 60 liter cylinder based on the vehicle application and the size. Because there are two types of three-wheeler. One is front mounted engine and another is rear mounted engine. Okay. So based on the packaging and the size of the vehicle, this cylinder is selected by the OEMs and packaged on the vehicle. So it's a very simple. High pressure pipe will go to the regulator, and from row it will go to the low pressure hoses will be fitted from the other side of the regulator and go to the intake of the injector on the engine itself. This is some of the photographs of three-wheeler where it is fitted, how it has been fitted. So this is the rear side of the vehicle where cylinder is fitted just below the seat. Then this is the engine fitted in the front. And you can see the ECU, they have packaged it and it having a very special couplers. So the most important part of what I feel for the student is that you should have a proper wiring harness, because it is a very important part. This engine is equipped with all sensors, actuators, and so if suppose wiring harness is having some fault, this starting mechanism and operation becomes very tedious, and finding the fault will be very challenging. So I think you need a support here from OEM of like Atul Auto and Advantek to have a proper wiring harness to suit your buggy application, because three-wheeler application will have all these other features of the vehicle wiring harness also. So you need some support from them. And of course, we are going to support you also, considering the requirement based on the sensors and actuator on your buggy. Sorry. This is the typical wiring TD diagrams, which are terminal diagrams, just to show you that it will have so many ends to the wiring harness where different couplers will be there, which should suit this couplers requirement of the sensors fitted on the engine. So all these details are available with us as well as Advantage. They can also provide, but you have to locate a proper wiring harness supplier who can able to fulfill your requirement for buggy for the proper operation. Coming to the gasoline, gasoline work as a lymphome on this engine. So it's having a 3-liter tank which is fitted on the vehicle with a small filter. Then electrical feed pump will be there, and it will be fitted to the intake or inlet nipple of the carburetor. So it is just like our two-wheeler application, how it is there. So similarly for a lymphome operation, very simple circuit has been done for three-wheeler application also. So I hope that similarly it will be done on the buggy based on your rule book requirement. This is some of the schematic how it is fitted on the vehicle. This is the rear mounted engine wherein this tank is fitted on the rear of the vehicle. Then the filter will be going, then feed pump to carburetor. These are some of the engine accessories which will be coming to you as a loose, like a spin-on filter will give as a loose or as a spare. So in case any damage happens or it gets clogged, you can able to replace it by just putting a spanner and tightening it. It's 35 to 40 micron in pore size filtration and having a filtration area of 700 centimeter cube. And it's a Mahle air filter we are using for it. This is some of the layout of the air filter, because there was questions earlier also in the presentation how this air filter will be fitted. Usually air filter will be fitted on the chassis of the vehicle with the support of rubber hose. So I anticipate similar type of packaging is required for your buggy also. You can fit vertical as well as horizontal air filter based on your packaging space. And the rubber hoses are different. Rubber hoses are available in the market. But since our OMS pipes is also going to be connected to this rubber hose, what I suggest that it is worth to use similar three-wheeler applications readily available hoses are there. If in case you are stuck that these rubber hoses are not suitable for your buggy application, then I think you need to take support either from Greaves or Atul Auto. They will support you for this to have a proper intake hose making and for your requirement for the buggy. This is not in our scope. I don't know whether it has been in the scope of Atul Auto, but just to notify that it has to be connected through rubber hoses to the intake manifold of the engine to the intake of clean side of the air filter. Other accessories are this ECU. This will come as a loose. You have to fit on the chassis. Then thermostat will be fitted on the engine, but some of the OEMs, being for the packaging point of view, they will not ask for this thermostat. They will tell you give us loose. So thermostat helps us for maintaining the temperature or the cooling of the engine properly. So it starts at 72 degrees centigrade and we get fully open at 80 degrees centigrade with 8 mm lift. And usually, if suppose water temperature goes above 105 degrees centigrade, then the alarm and the light blinking will start on the dashboard of the vehicle. So everything is protected in the wiring harness. If it is required for the buggy application, then it is necessary to have that also. Other accessories are OMS. Now on your vehicle, on your engine, this OMS is going to be fitted. This hoses is also going to be fitted. But because in the last discussion we had in detail that everything has to be fitted on the engine. So this will be fitted on the engine itself. So this will not come as accessories for your requirement. Coming to the engine layout on the vehicle, there are two types of packaging now. You can see this is the rear mounting. I feel that in buggy also it will come as a rear mounting, wherein engine is fitted in a lateral direction of the vehicle, where this both the side tires will be there. If you see north to south, and this is a gearbox with integral differential, mostly what three-wheelers are using, and it is packaged directly on the engine. You can see how the air filter has been packaged and exhaust system is packaged. If similar type of design is been considered on your buggy application, that will be the easiest application for you. But of course, it depends on your design skills, how it is going to be packaged, whether it is to be packaged with the same gearbox or some different gearbox students are going to use. To my information, I think students had been at liberty to use a different gearbox to prove their vehicle performances. So it's only a suggestion. You can go for the different gearbox. But if you only thing is that whatever the engine we have calibrated it is based for the three-wheeler requirement. If in case students are going with a different gearbox, different gear ratios, then I think the team needs a GCL supports for recalibration of their buggy to perform well in all terrain requirement. I think there are hills and valleys, different tracks are there for the driving. To meet that requirement, I think GCL will support you for the calibration point of view. If in case gear ratios are varying substantially as compared to three-wheeler application, then only this calibration is needed from the engine side. These are the special tool. I think it is not required for you. This is only for the service and maintenance point of view. But just to inform you that some of the special tools are required for removing the flywheel, then pulley and other cylinder head requirement and everything. In case this happens and it needs to be required there, then GCL will support you. Our service engineer will come there and they will help you out to service your engine and clear your problems on the engine. Coming to the tightening torque and thread sealant requirement for this engine. These are just micro level information which will be available in our workshop manual also, which is going to be provided along with each engine. So this will be available, and this is mostly for the gearbox tightening side for the PTO, which type of nuts and bolts to be needed and what type of sealants is needed to fix it to the gearbox. So this is only for the packaging of gearbox to engine. That will help you some of the nuts and bolts. But as such, for the engine point of view, you need not touch it. These are the service schedule. Whatever is been, this is also available in our workshop manual. You have to just go through that, and based on the requirement, you can have to just, wherever it is called for cleaning, you have to clean it. Wherever you have to replace, you have to replace it. And you have to, wherever it is mentioned as a check, you have to just check it. So it's a very simple chart. Most students may not be requiring this, but I am not aware means what will be the durability and other things are required for your buggy application for the demonstration point of view. So I think this is the presentation I'm having from my side. If you had any other questions, you please put on. I'll ask. I can able to answer to your question.
There were a few questions in the chat box. First one, how to select tank and the diameter. Okay, what is the diameter of output shaft?
This you can say output shaft of crankshaft. You want output shaft, that is PTO crankshaft.
Okay, Mr. Yash Bhakre, can you please unmute and be clear in your question?
Shaft you are asking, this actually whatever this line you are looking for.
Actually, there is no mention of which shaft.
Okay, this diameter is almost 24, and there are two types of PTOs for this application. One is spline PTO and another is a conical PTO. So usually spline PTO is used universally for three-wheeler, which is in package on the rear side. And the conical cone type of PTO has been used where the vehicle engine is packaged in the front side. This is basically mostly based on the requirement of the clutch housing and the clutch fitment on the gearbox. So that depends how students want to package it. If my recommendation would be that if you put it in the back side, you have to take it this spline, and that is a standard spline wherein a 24 dia spline is used, and it can be is packaged very easily for small applications.
Yes, sir. Yes, sir. I have one question. When we look from side view of the engine, that yes, that no, that the view in which that output shaft is there, that's line.
This one?
This view should be inside you, that it is conical, right? It is
Just a minute.
conical, right?
I'll go some different slide also, so where it will be more clear. Yeah, you can see this is a conical PTO.
So for attachment of a gearbox, can we remove that, means that cover, that which is conical, so we can accumulate more space?
Actually, this is the standard dimension. What usually you can see the studs are there on the PTO cover. These are stud.
Yes, sir.
Just a minute, I'll go with the pointer so that I can able to. You can see these are the studs. Okay.
Yes.
So usually what happens whenever a gearbox comes, this goes and rest on the stud and at this PTO cover. Okay. And the bolts and nuts are tightened to this 6 stud.
Yes.
And whatever this crankshaft is there, it is having a tapping. Okay. M12 tapping. And there is a bolt. That bolt will be provided by us. So M10 or M8 tapping.
So, sir, that output cover is according to that whichever that you are using in three-wheelers and all that, right? But means according to their gearboxes. So can we just remove that and we just want that shaft? Hello, sir.
Just a minute. I think there is a connection issue from sir's side.
Yuvraj, I'll take this question. Once Kaleem sir joins, just let me know. So, team, just for your information, the engine cannot be hampered. Okay. So, the same application what we are doing in hBAJA. Okay. So, this is how the engines are being provided, and you have to use completely in the stock condition. No retrofitment or anything is allowed. However, like you can make a sleeve to fit that, to fit to your output box, because that whatever you are asking, that PTO that cover to be removed, it will
Yes, sir.
there are certain leakages which it is arresting. So engine has to be used as a stock, and accordingly you have to design your transmission.
Sorry. Yeah, I got disconnected.
Yes.
Yeah, what's your question actually?
Actually, sir, that your that PTO cover is according to that whatever applications like three-wheelers are in market. So can we remove that PTO cover according to our
No,
gearbox?
no, no. No. You cannot remove that PTO cover and attach directly to gearbox because the surface finish now this comes under the matching of the crankcase to PTO is almost 5 micron machining is there. So I doubt whether gearboxes and the casings will be available with this 5 micron accuracy over flatness and other parallelity requirement.
Okay, sir.
So whatever the gearbox is there, that has to be fitted on the PTO cover itself. I don't know whether I can. You can see this PTO cover. This is
Yes,
better
sir.
picture. Yeah.
That is
So this
conical.
it's already having a surface finish where some spigot arrangement is also there. Your gearbox will come and directly rest on the studs, and then you can tighten the nut through the nut runners.
But usually that gearbox is not as big as, so that's why I am asking that PTO core which is conical. So instead of that cone, we just want.
So what I suggest that instead of we should have some CAD model. If you can able to share some CAD model to me, where emails are available, then I can able to comment on it, and I can suggest to you means how it can be packaged better on which type of on the engine side.
Simple. Coming sort of this side. So I was telling the teams, like as you have rightly pointed, that they have to develop the output shaft accordingly, and accordingly the rear end of the they have to accommodate in the roll cage, and engine as such has to be used in the stock condition. So you can think of making an extra sleeve and try to get the joints and everything. And once we are discussing with like once the vehicle integration topic is taken by Atul Auto, we can get some more inputs in that. So as such, engine has to be used in complete stock condition. No modification, no retrofitment on the engine is allowed as per rule book. Yes, sir, you can take it.
Yeah.
Okay.
Any more questions?
Yes. Mr. Piyush Balia wants to say something. I think.
Kalim sir, this is Piyush.
Yeah, Piyush, good morning.
Good morning. Engine already freeze, or we can have an option for FE cover and RE cover. So they can select among them which is more suitable to their gearbox, because we have a two type of option PTO cover.
Yeah, Piyush, we have not selected which options they can able to. Choice is based on the BAJA team. If suppose they want to mount it front mounted conical, we can able to offer them front. And if it is they want to mount it at rear, we can able to give a spline type. So both engines are
Yes, sir.
options
So
are open.
we can share PTO cover to them, so they can select which is better according to their gearbox. Because we have a two type of option to manage with gearbox.
That is right.
Yes.
So I think skin model we are going to provide to them. So, soon.
Okay.
So there's a question like, can you
And
explain?
one more thing, Yuvraj, I want to add. Piyush and Kalim sir, like as we are already in the process of that POC making. So from there also, once we are integrating everything, so maybe we'll also be getting an idea which one is a perfect fit, and that anyway we'll have a detailed with vehicle workshop. So that also can be given as an input to the teams, like maybe in next 1 month or something. So that also can be confirmed in due course of time.
Yes.
Okay.
Sir, can you explain the working of the RR unit? There's a question.
Yeah. If you see my screen will be available, I think, in front of you.
Yes, sir.
Yeah. There is a flywheel. Inside the flywheel, there is a magnet. I'll go to next slide also. This is the flywheel. Magnet is pasted inside the flywheel. And inside this magneto, this stator will sit. Okay. So what will happen when engine rotates? Okay. As soon as this engine rotates, because of the AD generation, AC current generates here. And this AC current will go to the regulator, because we don't require AC current. We need a 12-volt DC for all our vehicle requirement and other battery conditions, either for vehicle charging system or vehicle lightning system, or any other application we need a DC current there, or for the starter motor also. So this AC current will go to the regulator. It will convert and regulate to a regulated 12-volt DC output. And this output will be utilized, one for charging system of the battery, and other it will go for other vehicle requirement, wherein say starter motor is there. But starter motor needs support from battery also. But since the battery is going to be drained when we are using the starter motor, this battery has to be charged continuously. So this DC charge will help to charge battery as well as to give DC current for the requirement like headlamp or wiper requirement, which are the essential requirement for three-wheeler. So this is a simple mechanism, magneto type. Hello, Saurav.
And I think it is clear. Mr. Anjan Kumar, is it clear to you, the question you asked? Okay, sir, it's clear. There is one more question. Will, along with the ECU unit provided along with engine, will the harness will also be provided?
Harness, I just saw it's a very important question. You know, this project will be driven through harness only, because this buggy, I have not seen this actually, how it looks, but I want to share my experience on that. Sorry, I'm just going to the TD diagram one by one. And I shared the TD diagram. here it is. So this pin details will be available from the Advantech to us. Now there are many people who makes this wiring harness based on our requirement. And this wiring harness is reason is that what I suggest you go and take support of Piyush also, because Piyush may be knowing who are the wiring harness, who makes wiring harness based on the coupler requirement, because sensor couplers will be available to you, but it is a meeting of male and female couplers, and the female coupler usually will be on the sensor side and male coupler will be on the wiring harness side. It depends vice versa. It depends on the sensor how it is. So these all sensors, couplers should be available with the wiring harness manufacturer. So you have to have a professional wiring harness fellow who can able to support you for making this wiring harness. If in case three-wheeler wiring harness is going to be adopted by small modification, that is the best, easiest route, but it will require some effort of engineering there, wherein students has to put some effort to study how this wiring harness works and which terminal and which pin is being matched to which pin of the sensor. So my suggestion is that we will support you, no doubt about it. But I think major contribution will be coming from the vehicle side. Saurav. This terminal diagram will be available. We can share it. But important is that from whom you are going to make this wiring harness. Neither engine, we are not supplying you wiring harness. Whether Piyush, are you supplying wiring harness?
Yes, sir. We are supplying the wiring harness, but I don't know exactly they are going to able to use or not. Because once they package the vehicle, which are the other electrical components other than the primary system, headlamp, tail lamp, which are the other electric component. Based on that, they have to design the wiring harness with this terminal diagram and existing circuit diagram for basic performance. So we have a wiring harness, but they can't use as it is because they have to change branch location, branch length. Yeah, they can use same coupler, same terminal function will work, but they have to change according to their vehicle, where it should be branch location, where it should be branch length, and which are the other electrical components other than our regular vehicle. So according to, they have to add or delete coupler and pins according to mating parts. So there must be another one major task to integrate by the team.
I think, Saurav, this is an important point. We never discussed this in any of our previous meeting also. My suggestion is that I think you have to record it as one of the critical for the project. Something has to be weightage there properly in your rule book also, this wiring harness and other things. If suppose it is already been there in your rule book, wiring harness, then not a problem. But if it is not there, it has to be added in the rule book. Hello?
Yes, sir. It has been recorded. I'll inform sir. Sir, there is one more question. If I can go to the next one. Sir, are the sensors also provided?
Sensors will be provided on the engine. All sensors, actuator will be provided on the engine. Need not worry for that.
I'll request Mr. Yash Bhakre to restate this question or to ask it by another member. So I'll repeat it. Considering the amount of fuel the tank will carry, which will be the most suitable amount in considering the overall weight of the vehicle?
Cylinder, this is CNG cylinder. You mean to say cylinder or which tank?
He's mentioned the fuel tank. Like
Fuel tank for petrol.
Yes, actually, it's not clear. That's why I'm requesting Mr. Yash Bhakre to please unmute and ask the question.
Yeah, yes, please feel free to talk. No problem.
Okay. I think there's a connection. Okay, so Yash, please restate this question and put it in the chat box. We'll move on to the next question. What should be the distance between CNG cylinder and engine?
Actually, cylinder is means there is no specification usually mentioned, but usually cylinder is being mounted backside. Uh, Usually you can see on the vehicle side, it's almost 1 meter distance we used to observe. Piyush can able to comment on it.
Yes, sir. Yes.
But as there is no special specification that this should be the distance between cylinder and the engine.
Yeah,
What
yeah.
happens, cylinder has been packaged in such a way that it should not occupy the space in the vehicle. It should not consume the space.
Right,
So
right.
based on that requirement, what most three-wheeler people are doing, they are mounting the cylinder just beneath the driver. So that becomes that beneath the driver space, nowhere it has been utilized for anything. So that space has been utilized by this cylinder tank, and the low pressure and high pressure pipe been taken to the engine side.
Yes, yes.
So
2, 3
it depends
things.
on buggy. Hello.
Yes, yes, yes. Continue, sir.
No, for the buggy application, I really don't have experience. Means how the chassis is there, so that I can able to comment. But to my information, only driver can sit in the buggy, and there is small engine and differential backside.
Yes, sir.
So
One most important point is how they are going to cover the distance. What will be the refill frequency? So based on space, based on distance, they can select the cylinder length and diameter. There must be a entire chart available on the website of Rama Cylinder and as well as Econ Cylinder, which cylinders are approved by the agencies. So based on that, they can select the cylinder. But first, team has to study the available space and what should be the distance they have to cover. And again, the packaging, after packaging the vehicle, what will be the mileage of the vehicle? So all three parameters they have to gather tentatively, and they can decide what will the refueling frequency, and based on that, they can select the cylinder diameter and length.
And there is again a similar question: what is the diameter of output shaft of engine?
that will be available. I tell you, 24 dia is the diameter. But if you need all the detail, this presentation will be shared. Even that general arrangement drawing will be shared to you, Saurav. I'll mail to you. I think you can share it across to the team so they can study in detail how this general arrangement is there and what is the spline dia and the conical data dia of this engine. That I will share you today.
Okay,
The doubt will be clear.
there is one more question. Will the circuit diagram for connection be provided?
Which connections? Which connection? Sensors connection?
That isn't mentioned.
Usually, if it is there now, usually couplers, all the couplers are not similar. All different couplers are there and color identifications are there. So, very simple thing is that it will be a poka-yoke. The coupler which is respect to say lambda sensor will be fitted to lambda sensor only. The coupler which is required for temperature sensor will fit to lambda temperature sensor only. So there is a poka-yoke there, and there is a color coding also. So there is no mismatch that this coupler will go to that and it will be fitted in wrong way. So and that support will be provided. I think when the students will be there now. So Advantage will support, Atul Auto will support, Graves will support. We'll have small workshop there to support for all this requirement.
Also, in a particular harness which are going to provide by us, that harness have a label as well for critical connection. So, as said by Kalim sir, so all critical sensors and couplers have a label on the wiring harness. We are not able to hear you.
Hello. Yes, sir.
Yes. Yeah.
It's cleared, sir. There's one more question. Can we directly connect CVT to the output shaft?
So you can connect.
Okay.
Yeah, you have to match spline diameter and spline size.
Can we have a physical workshop? Yes, the physical workshop
that
will
is
be
planned.
held to everyone.
That is planned.
About it. Yes. Okay, teams. Any other question? Like this is a very important topic. So like if you have any question, please ask now. Either unmute yourself or comment it. So
I think Yuvraj, it's gone. I think
yes, sir.
it's done now. It seems.
There was one more question. Can the engine be horizontally or vertically tilt? It's
You
about
can tilt.
integrating.
You can tilt it. Okay, so that angle of departure and angle of approach also will share you. So it comes to be around for 30 to 35 to 40 degree you can able to tilt it. So tilting will not be a problem. But it should not be horizontally, totally 90-degree tilt is not advisable. 30 to 40-degree tilt, it's okay. You can use it.
Okay.
Sir, is
Yes,
it really necessary and mandatory to maintain the display for the sensors, which was coming from the data from the engine?
Oh, Bhaskar, can you just repeat me because there is some disturbance outside. I couldn't able to hear it.
Sir,
Please repeat
is
the
there
question.
any mandatory to maintain the sensor displays?
Sensor displays not required. I think
No.
not required. It's not mandatory.
Okay, sir. Thank you.
Okay, I presume all the questions have been cleared for now. If the teams have any further questions, they can put it like mail it to the BAJA communication. Thank you, sir, for your very descriptive presentation. The session has been optimally informed the students about the bifuel engine and overview of sound engineering practices which they should follow during its integration. So thanks a lot, sir. Now,
Thank you.
yes, sir. Thank you.
Thank
Now
you very much.
we'll be taking a short break of 15 minutes because what follows is a very informative session on integrating the fuel kit, the fuel injection kit. So like you can go freshen up and we'll be back in 15 minutes. Just be on time because it is a very important topic which you should all know about. So yeah, thank you.
Thank you.
Thank you, Kalim sir.
Thank you, everybody.
Session will start again at 12 sharp.
Okay.
Yeah. So I hope all of you are re-energized because what follows is a very important session. Knowing your components and integrating them is by far the most important and crucial part when it comes to designing and manufacturing a vehicle. To elevate your knowledge in this domain, we have Mr. Prasad Vispute from Advantech Fuel Systems. An alumnus of North Maharashtra University, Jalgaon, Mr. Vispute is working as a calibration engineer with a profound experience of 5 years in the automotive industry. The next hour would surely broaden your scope of understanding about the CNG injection kit. So over to you, sir. Hello.
Yes. 1 minute.
Yes, sir.
Can you screen is visible me?
Yes, sir. Screen is visible.
Okay. Say all of good morning. Myself Prasad Vispute from Advantech. Already introduced. Okay. Today's session is hello. I'm audible.
Yes, sir. You're audible.
Okay. Just start from today to total integrate parts from Advantech supply. Actually, Advantech is alternating fuel system for CNG, LPG, and bifuel. Okay. This is our BAJA's engine specification. Already Mr. Dr. Kalim sir is totally explained. I'm just review my last session. Our team is visited to our Advantic office from initial. The first session was completed with the basic introduction of regarding hydrogen base of BAJA vehicle. Uh, you can see. Hello. Huh.
Yes, sir.
This is general engine closed loop system. You can see this is ECU 1 number, 2 number is a carburetor assembly with TPS, 3 number is injector CNG and LPG, 4 number is LP hose, it's a low pressure hose, okay. 5 number is a low pressure filter, 6 number you can see LP hose regulated to filter.
Hello.
Prasad Kalim here.
Yes, sir.
Can you go in presentation mode? Actually, this slide is not clear to us. Just go in presentation mode. It will be helpful for us.
1 minute, sir. Okay, sir. Hello, sir, is it okay?
No, still it is not in presentation mode, it seems to be.
Yes, sir, I think this is blur image, so I think it's not visible to all of.
Okay.
I will explain you. Some और मेरे पास already all sides है, so मैं आपको बता सकता हूँ. Generally, sir, I will explain also Hindi, so better understanding to all of students. This is the general system, closed loop system of CNG system. Okay. These are the major sensors and actuators for closed loop system. One is ECU, electronic control unit. Second is TPS, throttle position sensor. TMAP, temperature and pressure sensor. FRTS, fuel rail temperature and pressure sensor. ECTS, engine coolant temperature sensor. O2 is O2 sensors, oxygen measurement sensor. CKP, crank position sensor. Vehicle speed sensor. Clutch switch. Actually, clutch switch is not a sensor, but next is actuator, ignition coil, gas solenoids, CNG injector, PWM valve, and starter solenoid. All these are the sensors and actuator. Are these are in both are combined with the closed loop systems. We are described one by one. Secondary function of ECU. Okay. Now in our BAJA vehicle A47 ECU we are provided. Model name is A47. Number of pins is A48 pins. ECU electronic control unit. Control a series of actuators, injector, throttle body, ignition coils on engine to measure the optimal engine performance. It does these by regarding values through the sensor, accelerator pedal, rail pressure sensor, TPS, TMAP, ECTS, crank speed sensor, vehicle speed sensor on the engine, interpreting the data using multi-dimensional performance maps, that is calibration maps, and adjust the engine actuator accordingly. Okay, it means all sensors and actuators, all the monitor by the ECU. Relaxation of fuel cutoff. It's another point. Okay. I'm just explaining shortly to one by one all EMS components. First, TMAP sensor. TMAP sensor is mounted on the intake manifold. This sensor is continuously monitors the air pressure and temperature in the intake manifold, and it's sent to feedback to the EMS ECU. Okay. It is mounted on inlet manifold. there should be any leakage from inlet manifold connection as it will affect the reading of this sensor. It also affect on our engine systems.
I think slide is same. It is not changing. We are seeing general engine closed loop block
Okay.
diagram. We are seeing that slide.
Actually, I changed, sir, but 1 minute.
It's now it has. So you can like just press F5 key.
1 minute, sir. Screen.
Okay.
Now visible?
Yes, sir, it's visible. You can just press the
Another slide
F5
also.
key for putting it in the presentation mode. Just press the F5 key and it would be more clear to us.
Now is it okay?
Yes, sir.
Also, you can select presentation mode. That icon is right side
At the
in
bottom.
orange color corner, nearby zoom in, zoom out.
Bottom right.
Uh,
One minute.
Just press the F5 key. Yes, yes, it's done, sir. Correct.
okay, okay.
Now okay.
Yes, sir, it's visible. You may start.
Yes, sir. Okay. Sir, TMAP sensor. Actually, then oxygen sensor, main component for closed loop system. It generates the voltage between the 1 volt to 0, 0 to 1 volt actually. Yes, 0 volt is less fuel and 1 volt is a more fuel. It means 0 means a lean side and 1 is a more side. Lean mixture and rich mixture. In engine start condition, its output should be always fluctuate between 0 to 1 volt. Provide this heater element as this sensor works only the higher temperature. O2 sensor default value is 0.45 volt with the just ignition switch turn on. Help ECU to determine the correct amount of fuel to deliver to engine. The major function is oxygen sensor to measure the oxygen in the exhaust, and this information given to ECU. Then ECU is monitored and it's uh, deliver and can understand, sir? Hello.
Yes, yes, yes.
Okay. Next is coolant temperature sensor. Its working range is 0 to 5 volt. It measures the engine coolant temperature and gives a signal to the ECM. In our, I think in our BAJA vehicle, I think coolant is not provided. Correct? Coolant system is an air cool engine. Here surface temperature sensor also call for the coolant temperature sensor. It is mounted on the cylinder head assembly. Temperature sensor is a NTC. It means negative temperature coefficient. Resistance type. It's a type NTC type. It helps to ECM to change the fueling injection timing depend on the feedback of coolant temperature sensor. It's generally in a brass or it's generally in a two pins. In You also show in TD diagram there are two pins. Next is a ignition coil, dry type, mounted with the two holes in our GCL engine. Ignition coil act as a transformer. It transforms the low voltage 12 to high voltage up to the 30 kilo volt. It helps to create a spark to jump the gap between the spark plug and through the ST cable of ignite fuel. Okay. There are some cautions. Don't use the ignition coil other than the OEM supply as it cause misfiring chances हो सकते हैं. अगर आप कोई दूसरा यूज करते तो मिसफायरिंग के चांसेस हो सकते हैं. जो स्पेसिफिकेशन से दिया है वही आपको यूज करना है. सेवरल डैमेज टू कैटकोन. समटाइम आपका कैट को भी also डैमेज हो सकता है अगर मिस फायरिंग है बहुत ज़्यादा हुई तो. Engine and other aim. Always mount the coil using a 2 bolts. You can see in pictures. Mm. Replace the bracket of ignition coil if broken, as excessive vibration can internally damage the coils. Sir, again I described some regarding ECU, some specification. Basic function of ECM: control the ignition coil for spark generation, control the injector and high pressure regulator solenoid valve for fuel delivery controls, control the airflow to engine electronic throttle control, run the following lamps and gauges on the dashboard also on instrument cluster: fuel gauge showing CNG pressure, low fuel lamp, engine overheat lamp, mill lamp, sail, neutral lamp, as per our as per our need. Technical specification: it's a ECU minimum operating temperature minus 40 degrees Celsius to 105 degrees Celsius. Storage temperature also minus 40 degrees Celsius to 125 degrees Celsius. Operating voltage minimum 8 volt to 16 voltage. Weight is 185 grams. Communication is a major. It's communicated by CAN or K lines. Next, the CNG system layout. This is the CNG and LPG system layout. You can see uh, basic cylinder, tank wall, cylinder. Hello, my screen is visible.
Yes sir, yes sir.
हाँ.
Screen.
CNG सिस्टम लेआउट आप अभी इसमें देख सकते हो कि CNG टैंक है, LPG टैंक भी है. मैं दोनों का एक सिमुलेशन किया है, सिमुलेट किया है एक लाइन डायग्राम में कि आपका एक बेसिक कंस्ट्रक्शन क्या है. CNG टैंक वॉल, high pressure pipe from tank wall to regulator, and regulator to filter low hose. Actually here pressure is low, so that's why it's called low pressure hose. From tank to regulator, high pressure. So high pressure pipe, it's generally in a carbon steel or SS stainless steel. Then filter to injector, low pressure hose. Yes, this is a basic line diagram of CNG tank to injector. Okay. Now, in our generally CNG tank wall, 200 to 250 pressure is storage. The tank wall is main function here to on off or the storage. I will explain in more in next slide. Basic I just show to you 1 minute. Our CNG tank wall is minimize the tank pressure from 200 or 250 bar to 20 bar. Okay. Then 20 bar pressure is is minimized up to 2 to 3 bar. Then it goes to the injector, because our injector working range is 2 to 3 bars. Okay. Like as LPG. LPG already is in a low pressure, so minimum max temperature, max pressure is 10 bar. So you can see the LPG cylinder 10 bar, multifunction valves. In multifunction valves, solenoid also fitted to operate the CNG flow on off then tank wall to regulator with a low pressure hose, then a regulator to injector, in between filter also mounted to any dust impurities are blocked here. Uh, Okay, this is general system layout of CNG. In our BAJA scope, main components are these are the main components which are provided by Advantage. So first is CNG cylinder, it's not cylinder, but cylinder tank wall. Tank wall also mounted filling nozzle, CNG pressure gauge, micro switch, high pressure regulator assembly with the CNG solenoid, with benzo with T assembly, CNG filter, injector, high pressure hose and low pressure hose. Okay, escape CNG cylinder, all parts which are provided by Advantage. It's a bomb. Already I have shared with Dr. Ora sir and other teams. Uh, Now it's cylinder wall, nozzle, pressure gauge, micro switch is the main tank wall assembly. Then second number is high pressure regulator assembly with solenoid with low pressure hose also fitted along with. Then third number is CNG pressure steel tube, 6 mm outer diameter or 4 mm inner diameter. Along this CNG tube, ferrule also provided by Advantage, M12 fine thread, and ferrule nut also ferrule nut is M12 fine threaded, or ferrule also 6 mm provided by Advantage. Four number is CNG high HP tubes mounting clamps, and fifth number is removal and installation of tool CNG cylinder wall. Okay, we are now all components described one by one. First is CNG cylinder tanks, which are not provided by Advantage, but now this information I will use from my side to all. The cylinder wall is to be fitted by uniformly applying the Teflon tape of IS 3465 having a width of 3 by 4 and minimum thickness of 40 micron for a minimum 2.5 round. सो इन शॉर्ट आपको जब भी टैंक पे फिट करना है, सो आपको आईएस मार्क का ही टेफ्लॉन यूज करना है. उसका मिनिमम आपको हाफ 2.5 राउंड आपको वाउंड करना है क्लॉकवाइज. ओके, then second, CNG cylinder wall is torque. हाँ, it's main point. Gas cylinder wall is torque minimum 140 plus Newton mm via automatic process. ओके, आपको जब भी टैंक होल टाइट करना है सिलेंडर के ऊपर, सो फर्स्ट ऑफ ऑल आपको सिलेंडर टैंक जो है उसको एक फीचर में मतलब होल्ड करना है. देन आपको जो टैंक होल है उसका टॉर्क ये 140 न्यूटन प्लस होता है. ओके, और ओके, और ये ऑटोमेटिकली प्रोसेस थ्रू होता है. जनरली अगर आप देखोगे 3 व्हीलर 4 व्हीलर जो प्रोडक्शन प्लान है वहाँ पर ये ऑटोमेटिकली होता है. नेक्स्ट, थर्ड, पीरियोडिकल मैनुअल वेरिफिकेशन चेक्स आर रिक्वायर्ड. और इसके लिए आपको और एक पॉइंट है कि मैनुअल आपको इसका ये करना है, पीरियोडिकल वेरिफिकेशन करना है. Checks are required to keep along result with date, time and identification codes. Sir, next CNG cylinder tank wall, which provided by Advantage. The purpose of CNG tank wall are to control the regulate the flow of high pressure natural gas from station to the tank. Okay, these walls open and shut accordingly in response of the gas pressure under the strict safety standard. ओके, ये ऑपरेटिंग कंडीशन है उसके। एप्लीकेशन ऑफ फ्यूल इन सीएनजी, मैक्स वर्किंग प्रेशर एमपीए, हाँ एमपीए 20, ब्रश डिस्क रोस्टिंग प्रेशर 30 प्लस 10% एंड फिजिबल टेम्परेचर डिग्री 125 प्लस और माइनस 10। आप ये अभी वॉल में देख सकते हैं, मैं आपको थोड़ा डिस्क्राइब करता हूँ। ये टोटल ब्रास का टैंक वॉल है। ये जो रेड कलर में है ये नॉब है, फॉर दिस साइड क्लोज, फॉर दिस साइड ओपन। उसके बाद ये जो है, एक मिनट, हाँ थोड़ा यहाँ पर आपको मोर एक्सप्लेन होगा। ये डस्ट प्लग है एक्चुअली, यहाँ से ये अपना एक फिलिंग यूनिट है एक्चुअली। गैस स्टेशन पर आपको यहाँ से फिलअप करना है, जो टैंक वॉल में आपका गैस फिलअप करना है फ्रॉम डस्ट प्लग। डस्ट प्लग के नीचे माइक्रो स्विच ऑल्सो प्रोवाइड किया है, तो एक सेफ्टी पर्पज है। मैं आपको आगे डिस्क्राइब करता हूँ, ठीक है। आप देख सकते हो कि टैंक वॉल है, ऑन ऑफ डायरेक्शन ऑलरेडी मेंशन होता है टैंक वॉल पे। नेक्स्ट एंड इसका है जो टी कनेक्टर है, ब्रास टी कनेक्टर। ऑन ब्रास टी कनेक्टर प्रेशर गेज इज माउंटेड। You okay, then we will change this tank wall. I'm just explaining the key benefits. Rigid mounting directly on the CNG cylinder, no additional mounting is required. हाँ, टैंक वॉल के लिए आपको कोई एडिशनल ये नहीं देना है कि ब्रैकेट्स वॉट एवर, आपको डायरेक्टली ये टैंक वॉल पे ही माउंटेड होने वाला है। ब्रास मटेरियल है, टाइटनिंग टॉर्क इज 210 plus 10 Newton meter. Okay, in our three-wheeler application, 210 plus 10 Newton meter torque is applied. ओके, इसमें एक सेल्फ क्लीनिंग फिल्टर होता है एट इनलेट। ओके, चाइल्ड पार्ट्स अवेलेबल, इसके चाइल्ड पार्ट्स भी आपको मिल सकते हैं। ओके, repairs cost reduction, integrate pressure gauge T, manual shut off and filter, single block construction. Okay, हाँ, next contact type micro switch. Okay, then important instruction. While working on a high pressure line, first ensure the cylinder tank wall shut off wall knob is turned to close. आप जब भी कुछ वर्किंग कर रहे हो सीएनजी रिगार्डिंग कुछ पाइपनिंग या तो आपको कभी भी ये इंश्योर करना है कि ये टैंक वॉल ऑलवेज क्लोज होना चाहिए, क्लोज में ही आपको ये वर्किंग करना है, ठीक है। अगर समझो आप कोई हाई प्रेशर पाइप खोलना चाहते हो, कुछ क्रैक हुआ है, कुछ बेंड हुआ है, सो दैट कंडीशन में आपको इंश्योर होना है कि ये क्लोज होना चाहिए। टैंक वॉल क्लोज करने के बाद आपको व्हीकल स्टार्ट करना है, और जो पाइप में जो गैस होता है पाइपलाइन में वो ऑल्सो आपको रिमूव करना है, कंज्यूम करना है। ओके, नेक्स्ट बिफोर लूजनिंग द टी, हाँ, और ऑल्सो आप अभी एक ड्राइंग में देख सकते हो, सेकंड ड्राइंग में प्रेशर गेज को एक ये दिया होता है, एक्चुअली एक ग्रू दिया होता है। बिफोर लूजिंग द टी प्रेशर गेज इंश्योर द एलन की टाइप लूज स्क्रू मस्ट बी रिमूव, ये सेफ्टी पर्पज के लिए दिया है। ओके, हाँ, इसमें एक इम्पोर्टेंस मैं आपको डू और डोंट्स बताना चाहता हूँ। लाइक वर्किंग ऑन हाई प्रेशर लाइन, इट्स इंश्योर द सिलेंडर वॉल शट ऑफ वॉल नॉब इज टर्न टू क्लोज। जैसे कि मैंने लास्ट बताया आपको कि जब भी वर्किंग करोगे तो ये वॉल क्लोज चाहिए। बिफोर लूजनिंग द टी गेज साइड फर्स्ट इंश्योर द एलन की टेप स्क्रूज मस्ट बी रिमूव। ओके, यहाँ पर एक एलन स्क्रू दिया है, यहाँ पर लिखा है बिफोर ओपनिंग और टाइटनिंग द प्रेशर साइड टी असेंबली प्लीज इंश्योर द एलन की मस्ट बी रिमूव्ड। ओके, डोंट्स, हाँ, आप अभी डोंट्स के लिए भी आप थोड़ा पॉइंट्स रेफर करेंगे। Don't close or remove the pipes without the ensure the tank wall knob is off. Okay. Then micro switch. ये माइक्रो स्विच आपको इसमें दिख सकता है, ठीक है। माइक्रो स्विच जैसे सेफ्टी पर्पस के लिए दिया है कि अगर आप सपोज आप सीएनजी स्टेशन पे गए और आपने 10 प्लग निकाला फिलिंग इन गैस फिलिंग के लिए और आप ये भूल गए तो आपकी व्हीकल ही स्टार्ट नहीं होगी। ओके। और दूसरा एक पर्पस है कि अगर यहाँ पर एक एनआरवी वॉल दिया रहता है इन अवर ब्रास टैंक वॉल, सो एनआरवी वॉल से कभी कभी बैक गैस आ सकता है और उससे प्रॉब्लम इश्यू हो सकता है। तो ये सेफ्टी पर्पस के लिए एक डस्ट प्लग दिया है, वो डस्ट प्लग लगा या नहीं लगा है इसको डिटेक्ट करने का काम माइक्रो स्विच करता है। तो ये वन टाइप ऑफ का बोल सकते हैं अपन सेफ्टी फीचर्स। ओके। Important introduction about the micro switch. Micro switch. All vehicles are equipped with a micro switch, which assure that the vehicle goes off and does not start during the CNG fuel filling process. Okay. जब भी आप स्टेशन पर जाएंगे तो ये आप देख सकते हो। इंश्योर दैट द फिलिंग वॉल डस्ट प्लग इज प्रॉपरली इंसर्टेड। ओके। जैसे कि मैंने बताया कि ये माइक्रो स्विच डिटेक्ट करेगा कि फिलिंग वॉल का डस्ट प्लग आपने फिर से डिटेक्ट किया है नहीं किया है। एक्चुअली माइक्रो स्विच में एक कॉन्टैक्ट टाइप होता है, सो इसी को ये बताता है कि अभी ये डस्ट प्लग लगा है, इट मीन कॉन्टैक्ट हुआ है कि आपका डस्ट प्लग ये टैंक वॉल में लगा है। ओके। Ensure that the micro switch wire in the filling wall are connected properly. Okay. Okay. Is along with tank wall, CNG pressure gauge also provided. The CNG level sensor is placed immediately after the first stage of reducer or after the cylinder wall outside the tank. CNG cylinder wall, first stage and level sensor are placed under the driver seat. एक्चुअली ये मैं थ्री व्हीलर के लिए आपको बता रहा हूँ, ये बाहा के लिए नहीं है, मगर जनरल सिस्टम थ्री व्हीलर में कैसे माउंटेड होती है एक मैंने आपको बताने के लिए ये फोटोग्राफ दिया है। अभी आप बाहा के लिए अपने को ये देखना होगा कि आप कैसा माउंटेड करते हैं, वहाँ की फ्लेक्सिबिलिटी के डिपेंड। ओके। इट्स मीन्स आपको टैंक वॉल पे प्रेशर गेज भी दिया जाएगा, वो आपको इंडिकेट करेगा कि टैंक में कितना प्रेशर है। ओके। और ये प्रेशर गेज के ऊपर आप देख सकते हो एक्चुअली इसमें एक लेवल सेंसर भी डिटेक्ट होता है। एक्चुअली ये इलेक्ट्रिकली हेलो हेलो
यस सर।
हाँ, एक्चुअली ये प्रेशर गेज के ऊपर एक सेंसर भी दिया है, आपको ये डायरेक्टली मैकेनिकली तो बताएगा ही प्रेशर गेज कितना है, मगर अगर कस्टमर पीछे जाके थोड़ी देख सकता है कि भाई अभी टैंक में कितना प्रेशर है, सो इस पे एक सेंसर दिया है, वो अकॉर्डिंग टू द प्रेशर इलेक्ट्रिकल फॉर्म में आपके इंस्ट्रूमेंट क्लस्टर पे मतलब ड्राइवर के सामने ये आपको एलईडी फॉर्म में बता सकता है कि अभी लेवल रिजर्व है, 1 है या 2 है, या प्रेशर में बता सकता है अभी 40 बार प्रेशर है, 30 है, 20 है। तो इसके लिए एक सेंसर भी दिया है, ये आप यूज कर सकते हो। ओके। ठीक है। माउंटिंग कनेक्टर मैं थोड़ा डिस्क्राइब करता हूँ रिगार्डिंग द प्रेशर गेज। माउंटिंग कनेक्टर्स सिमिनिटो शॉर्ट पार्ट एक्चुअली पार्ट नंबर, ठीक है। ओके। हाँ, इसके लिए आप मेजर एक ही है आपको कि आपको इसको टाइटनिंग के लिए 14 टू 18 न्यूटन मीटर का टॉर्क देना है। ओके। ये आपके लिए की पॉइंट्स है। देन ऑल्सो आपको एक नोट करना है कि एक्चुअली ये प्रेशर गेज के ऊपर एडवांटेज थ्रू एक कवर प्रोवाइड किया जाता है, सो वाटर कैन अवॉइड, या अपन वाटर को अवॉइड कर सकते हैं फॉर एंटरिंग के लिए। बहुत टाइम क्या होता है कि वाटर अगर एंटर हुआ so wiring short हो सकती है. Okay, so cap also provided from Advantage. Okay, uh, CNG tank wall with level sensor. The main function of CNG pressure sensor is mounted on the tank pressure gauge. It works on the potentiometer logic. जैसे कि मैंने लास्ट बताया आपको, ये सेंसर माउंटेड होता है प्रेशर गेज पे. ओके, पोटेंशियोमीटर लॉजिक, इट्स वर्क्स ऑन अ पोटेंशियोमीटर लॉजिक. इसमें एक सेंसर होता है प्रॉक्सिमिटी, वो इंडिकेट करता है लेवल मेजर करके. ओके, it's the electrical component used to convert the pressure signal in the tank in an electrical signal approximately in the range from 1 volt to 5 volt. हाँ, इसका बेसिक जो फंक्शन है 0 to 5 volt, ये इसका वर्किंग रेंज है. ओके, द CNG tank wall, CNG tank pressure gauge, needle position change based on the CNG tank pressure. The tank pressure sensor monitors the position of the needle and send the feedback to the ECM. Okay, आपको अभी इसमें समझ सकता है कि ये प्रेशर बाय मैकेनिकली बताएगा. इसमें बर्न ऑन टिप्स होती है और ये सेंसर मेजर करके ECU को बताएगा. ओके, इसका हमने कैलिब्रेशन किया रहता है. ओके,
Hello.
यस.
Hello. Yes, some teams are requesting the explanation in English.
Okay,
So,
okay, okay, okay. Right, okay. Uh, then third point is the CNG tank pressure gauge needle position change based on the CNG tank pressure. Okay, the tank pressure sensor monitor the position of the needle. Tank pressure sensor, it's monitor the position of needles and send the feedback to the EMS ECU. Okay, which means sensor is detect the level and send to the ECU. EMS ECU interprets the tank gas pressure based on signal sent to the tank pressure sensor. Fourth, if CNG pressure is max 200 to 220 bar, the voltage value is 0.33 to 0.25 volt or vice versa. It varies between 1 volt to 5 volt. Okay, it's a calibration part, so it's not important for us. Fifth, EMS issue send the fuel gauge level, okay, and low fuel level feedback to instrument cluster also indicate the fuel quantity in CNG tank. Okay, then main part is CNG regulator. You can see image. This is a aluminium plus brass T. CNG pressure regulator performance actually as shown in our PPT. Inlet pressure range is 10 bar to 260 bar. Flow rate up to 10 gram per second. Okay, then this CNG regulator is applicable for both LPG and CNG. This regulator inlet pressure is 10 to 260 bar, but it converts into 2.5 to 5 bars. Okay, our requirement is for injector working 2 to 3 bars. Okay, so main function is regulator to convert the high pressure into as per our requirement in our application 2 to 5 bars. Okay, outlet pressure. Just see your diagram here. Most child parts are specification are shown. One number is pressure regulator assembly. Okay, then second number is bolt by bracket for tightening. A bracket also provided with along CNG regulator. Third is a vacuum hose. Fourth is a clamp spring nut and bolt. Fourth one. Fifth is a benzo. Benzo is a major part. Benzo is Okay, then regulator outlet nipples. Okay, 1 minute. Fifth number is a benzo with T assembly. It means it's a solenoid wall. Okay, I will explain more in next slide. First, CNG regulator. The main function of CNG regulator function is to accept the high pressure CNG from the cylinder through the inlet and deliver low pressure regulated CNG through the outlet. Okay, it's a single stage regulator, so it's reduced the pressure in a single stage from 200 bar to 2.5 to 3 bar. To regulate the pressure coming from gas cylinder, okay, a large filter at inlet. To increase the life of regulator, filter can be replaced externally. Okay. The regulator hello, the regulator, sorry, the regulator maintains the specific outlet pressure 1.8 to 2.1 bar at defined inlet pressure range and allow gas at set pressure to flow to engine with the CNG injector when solenoid is engaged. ओके, इट्स मीन्स लाइक जब आपका सोलेनोइड ओपन होगा, when our solenoid is commanded from ECU, that time solenoid is open and the our high uh, gas pressure 200 bar is reduced into the 1.8 or 2.1 bar. Okay. The main function of shut-off valve, uh, component description operation of shut-off valve. This valve is fitted on a CNG regulator. Gas solenoid electrically increase or decrease allow or not the fuel flow through the component. Okay. The activation of valve is setting up with the specific strategy in ECU. Gas solenoid or shut-off valve is an electromechanical component in which the solenoid is excited to generate a magnetic field that is used to move the shutter plunger to open or close the gas flow through the valve to the injector. इट्स मीन्स ये टी असेंबली में एक आपका प्लंजर होता है. ये कॉइल जब भी चार्ज होगी, वेन एवर कॉइल इज चार्ज, दैट टाइम प्लंजर इज ऑपरेट अप एंड डाउन. So when charge coil, the plunger is upside, then gas flow is uh, go from one side to another side. It's a main function. It's operated by the major sorry ये जो coil है, this coil is operated by ECU when okay, yes. One question is prevent the solenoid from any dust or metal debris as it keeps the plunger or valve stuck in one position. Use only company recommended petrol solenoids. Next is pressure filter. You can see the total child parts in filter assembly. The one is filter casing, low pressure filter. Actually, this is a low pressure filter with fuel rail pressure also sensor also provided. One, as mentioned, one is a low pressure filter. Two is the outlet cap. Okay. Then third number is filter cartridge. Four number is uh, hose from filter to injector. Okay. Then five number is clamps, mounting clamps. Sorry, mounting fitting clamps and outlet cap O-rings. It means these are the child parts of filter assembly. Okay. हाँ, CNG filter assembly with fuel rail temperature sensor. Actually ये फिल्टर के साथ ही आपका फ्यूल रेल टेम्परेचर सेंसर ये होता है. ठीक है. Install after the high pressure and before the injector. Uh, our filter assembly location after the high pressure regulator or before the injector. Okay. Filter the gas coming out from the high pressure and dampers to absorb the negative pulse coming back from the injectors. इसका मेन फंक्शन यही है, filter the gas coming out from the high pressure regulator and dampers to absorb the negative pulse. जो negative pulse आते हैं from injectors वो ये करता है absorb. Particulate the pre-filter 10 microns. ये जो फिल्टर है इसका ये 10 माइक्रोन से 3 नंबर वाला आप देख सकते हो का स्ट्रक्चर. Prevents injectors from any debris, oil and moistures. Okay. Fuel rail pressure sensor packaged from sensing temperature and pressure of gas before injection. Some size is 15 ml. Okay. Inlet and outlet marks on body is provided. You can see inlet and outlet mark also provided by product. Okay. It means a direction already provided on the filter, so you can easily understand inlet from which side and outlet which side. Okay. Next is high pressure hose. Actually, this hose is fitted at high pressure line in our BAJA vehicle from tank wall to high pressure regulator. This pipe is used. This pipe is 6 mm OD diameter and 4 mm is inner dia. Okay, we describe one by one. CNG high pressure pipe. It is a 6 mm OD steel pipe and that carries the CNG from tank to the high pressure regulator assembly, HPR assembly. Okay. One number is pipe cylinder wall to HPR as per. One loop is also provided. Second, ferrule nut fine threaded. Then third number is ferrule 6 mm. Okay. An essential safety precaution for working on pipeline is not operate pipelines beyond their maximum operating pressure. Okay. This is general three-wheeler mounting of high pressure pipe and all CNG kit. You can see cylinder, tank wall, high pressure pipe. Last 4 number you can say regulator to injector, then engines. This is top view, this is side view. The major also important clamping also need if the 3M it means अगर आपका 300 mm के ऊपर हैंगिंग होता है, if 300 mm above pipes hanging होता है, so in that condition clamp should be provided. Okay. Next is high pressure hose regarding cautions. First, parts should not be come in contact with the mineral fluid during the cleaning or any other process. ये आपको इंश्योर रहना है कि ये कोई इसका मतलब इससे ऑक्सीडेशन वगैरह हो सकता है, सो ये आपको इसी जगह स्टोर करना है. Okay. Suitable protective cap for end of the ferrule nuts. Generally, we are providing a caps on both ends. Okay. Third is HP pipe shall not have a cracks or scratches marks. हाँ, आपको ये इंश्योर होना चाहिए कि उस पर कुछ क्रैक नहीं है और कुछ स्क्रैचेस मार्क नहीं है. Both ends of the tube shall be straight or burr free. Okay. Both ends ये आपको straight and burr free चाहिए. SST 96 hours for the white rust and 240 hours for the red rust. Okay. 6 HP tube homologation as per the 15716 2006. ओके, ये नॉर्म्स के हिसाब से आपको पाइप्स का डिजाइनिंग चाहिए, उसका लोकेशंस एंड उसका माउंटिंग्स. पाइप डायमीटर ऑलरेडी मैंने बताया आपको, आईडी इज 4 mm एंड आउट डाया इज 6 mm. हाँ, मेन इम्पोर्टेंट ये आपके लिए पॉइंट्स है कि टॉर्क फॉर द फेरुल नट मेटिंग द पार्ट 30 to 34 न्यूटन मीटर्स. Whenever you tightening the tank to high pressure regulator, the the ferrule nut torque is minimum in range 30 to 34 Newton meter. Okay, आप टॉर्क रेंज से ये फिटमेंट कर सकते हो. आपको 30 से 34 मीटर तक ये देना है न्यूटन मीटर तक टॉर्क. फेरुल एंड फेरुल नट कोटिंग. ओके, actually ferrule or ferrule and ferrule nut on zinc traveler silver coating is provided to resist the corrosion. Okay. 10 expansion loops are used in piping system to help the internal displacement and thermal movement. Actually, we are providing a one loop or two loops according to our requirement and actual fitment. If hanging or if generally one loop is also the provided to if expansion loop are used in piping system to help the thermal displacement and thermal moment. If thermal moment reaches a value that is the higher than the expected, expansion loop can be thermal displacement to minimum and deflect the traces from the piping system. Should more than one cylinder be installed, the piping between them must have a loop to absorb the vibration. Also loop are ये आपका vibration also absorb करेगा. Okay, इसके लिए आपको one loop is most important in our vehicle. Next, after the fitment of high pressure tube, we ensure the any leakage. So, Swagelok snow solution to be used for the leakage check instead of soap solution, not using general soap solution for checking the leakage, air leakage, gas leakage. Okay. Second is regular inspection. Get your CNG kit inspected and service every year by an authorized service facility. Okay, it means check the fitness in every year and our due date. Last is the major our main part for the tightening of the tank wall. We require a special tool. You see it, cylinder wall special tool. For tightening a tank wall, use a specific tool for installation and removal of CNG cylinder wall. Okay. आपको ये बाय हैंड नहीं यूज करना है कि इसके लिए आपको एक स्पेशल टूल प्रोवाइड किया जाएगा फ्रॉम एडवांटेज टू फिटिंग द टैंक वॉल ऑन टैंक. After that, some important points regarding the CNG kit fitment. CNG is a compressed natural gas, mainly consists of a methane more than 95%. CNG is filled in kg, not in liter, and filling quantity depend on a pressure and their temperature. CNG filling pressure is maintained at 200 to 220 bar at filling station as a standard in Pan India. The filling estimate capacity is depend on ambient temperature and pressure. Already, okay. Only use specific tool for installation and removal of CNG cylinder wall. Okay, already described in last sheet, last slide. Okay, fifth number. Wrap approx 6 to 7 suitable rounds of the Teflon tapes in a clockwise on threaded portion on a cylinder tank wall before the tightening. ओके अब जब भी टैंक वॉल पे सॉरी टैंक पे टैंक वॉल लगाओगे तब 6 to 7 सुटेबल राउंड्स आपको ये टेफ्लॉन टेप का अप्लाई करना है ओके 7 सीएनजी सिलेंडर वॉल टॉर्क 180 to 220 न्यूटन मीटर ओके 8 check micro switch for proper instead of dust plug in engine not crank just after the filling the gas okay micro switch आपको ये proper होना चाहिए actually micro switch is most important 9 minor leakage in LP line can be detected using iSmart live data monitoring RP fuel अगर in case in our system minor leakage so this leakage is not visible to us so in that condition we are provided sensors this sensor is already calibrated values it means it's measure this my range and this range is below pressure is in our system so it's detect the our line is leakage okay इट मीन्स आपके जो एप्लीकेशन है उसमें हमने एक सेंसर दिया रहता है वो डिटेक्ट करता है कि अगर ये मेरे रेंज के नीचे अगर मेरा फ्यूल प्रेशर गया तो लाइन में कुछ तो भी लीकेज है और वो डीटीसी आल्सो प्रोवाइड करता है डीटीसी आल्सो प्रोवाइडेड बाय रेल प्रेशर सेंसर if agar a fuel pressure is below the specific limit so it's showing P0087 DTC DTC means diagnostic trouble code to indicate the in system our fault is created so as per this DTC we can go specific area to diagnose the fault okay if P0088 is a high pressure uh, system high pressure detect DTC okay and last is P0093 fuel system leakage large leakage R for leakage in LP pipe इन केस अगर लो प्रेशर पाइप में लीकेज है लार्ज सो P0093 ये कोड हमें डिटेक्ट करता है नेक्स्ट इज बेसिक सेफ्टी प्रैक्टिस फॉर सीएनजी टेक्नीशियन ये अपने को बहुत इंपॉर्टेंट है शट ऑफ वॉल ऑफ इंडिविजुअल सिलेंडर वॉल्स और डिस्कनेक्ट सिलेंडर इलेक्ट्रिक सोलेनोइड वॉल्स ओके start the engine 1 minute one is shut off valve all of the individual cylinder valves अभी ये मल्टीपल सिलेंडर के लिए है और सिंगल सिलेंडर के लिए also applicable है अगर आप कुछ काम कर रहे हो और अगर आपको काम करना है तो आपको इंडिविजुअल वॉल्व बंद करना है हर एक so first shut off valve of the individual cylinder valve or disconnect cylinder electrical solenoid valve also second start the engine and let it run until it stall or shut off after a short while about 2 minutes try to restart the vehicle which should not start okay to verify that the cylinder valves have sealed in the closed position and have shut off the gas flow from the cylinders repeat the attempt of restarting the vehicle until you are sure the engine will not start okay if the engine will not run the high pressure fuel system should have very low pressure less than 150 psi okay to confirm this check the high pressure fuel gauge it is essential to verify the system has very low pressure before you proceed also remember that only the session of the fuel system downstream of the closed cylinder valve are depressurized and can be safety disassembled. Use two wrenches to open the fitting just to the point where gas being to flow. Okay, thank you. Are any questions?
Okay, it was a session loaded with a lot of information. So teams, you can go ahead asking any questions regarding system layout, integration, or assembly, because eventually you are going to do all these things. So better you make all your doubts clear. And this,
Already, I'm after my session. I am already. I'm provided this PPT also, all of, so you can better understand. Okay.
because your teams, you can either switch on your mic or put a question in the chat box.
हेलो सौरभ जी, आप जब ये फिटमेंट करोगे तो मेरा एक टेक्नीशियन वहाँ पर रहेंगे. ओके, तो ये आपको प्रॉपर फिटमेंट के लिए गाइडेंस कर सकते हैं.
Okay, thank you, Prasad sir. Okay, teams, if you have any questions, this is the time to ask. We'll wait for one more minute. Till then, do you have Kalimuddin sir here?
Yeah, any question?
Yes, sir. There was a question for the previous session. It was like, can we modify the hose of radiator? If yes, then the pump capable of pumping the coolant then?
Yeah. We can modify it, not a problem. But there should not be sharp bend or kink formation. Not a problem for that.
Okay.
Yes. Mhm.
Yeah. And I've already shared the presentation, Saurav, to you.
Sir, I have a doubt regarding the positioning of cylinder, sir.
Cylinder.
So, like where we have to place, it can be tilted or we have to keep it horizontal or vertical.
Horizontal in general practice, I think it's better. Collisions are also some your points. I think it's
Yeah, my question is reason is that if you are mounting horizontal, then that weight will not be an issue. It will balance the vehicle by its weight. If you put a vertical, then during turn and everything, you have to account for the proper means balancing of this unbalanced weight, because during turn there will be some inertia because of this excess weight of the cylinder.
yes, moment here sorting होगा after turning the point. Yes.
Yeah, if you can able to mount vertically and stability is there, not an issue, because pressure remains constant everywhere, and there is 200 bar pressure in it. So if it is vertical also, it will give 200 bar only. But stability of a vehicle is important if you are mounting vertical also.
So in our three-wheeler, four-wheeler, and heavy also mounted at the horizontally. Generally.
Yeah. Reason is the stability during turns and other things.
Yes.
Any more questions?
I've shared my presentation to you and the GA drawing also. So you can share to the team wherever needed.
Okay. Okay, teams, you will have all this presentation.
Sir, as you have given clarity that we can place it vertical or horizontal, should we place that below the engine or above the engine?
What is the question?
Like you have given clarity that we can place it vertical and horizontal. We can keep the accumulator below the engine or above the engine.
Accumulator means what do you want to say? Means
cylinder, sir. CNG cylinder.
Cylinder.
Yeah, yes, sir.
My recommendation, don't go above, because that will create a movement. It would be better if it is at the lower side of the vehicle side. That will be better, because it is a very heavy cylinder. It is not a light cylinder. So my recommendation would be that it should be towards the floor of the vehicle, not above on the frame.
But sir, as they have mentioned, there should be a gap of 1 meter, no, sir, from the engine and the
That
cylinder.
I'm sharing you with the experience of the three-wheeler, where you can see question was asked how the cylinder to be with respect to the engine. So question is that the three-wheeler doesn't have space to put near to the engine. Okay, so what the three-wheeler guys used to do, they used to place backside and engine in the front. And in case suppose engine is the back, so they will put in the front. So that distance accommodate almost 1 meter distance. So it is not necessary that 1 meter should be there. It could be half meter also. But after it should be within the rule book, and safeties should be maintained as per the rule books.
Thank you, sir.
Yes, ठीक है sir. Thank you. Then you may proceed to our next session.
Okay, so thank you, Prasad sir, for your valuable session. For telling us about the working integration and assembly of various subsystems. So it will surely help the teams.
Yes.
Now, before the last session, we'll have lunch break now. We'll continue at 2:10. Request all the teams to be on time for the next session because it's the most awaited one, where Mr. Hitesh Chaudhary will tell you about the simulation on the GT Suite software and also the parameter inputs as well. So we'll start at 2:10 sharp. So I'll meet you soon. Thank you.
Okay.
Thank you all the speakers for being with us. We'll continue at 2:10.
Yeah.
Okay. Good afternoon, teams. I hope you had your lunch. Just make sure you have your cup of coffee next to you because this session is a very important session and you all have waited for this session on GT Suits. So, is the screen visible?
Yes.
Okay. So simulation plays a key role in understanding the performance characteristics that can be sourced through the available systems. The access to GT Suite has surely provided you with a cascade filled of endless opportunities, but the key to that lies in today's session. We have Mr. Hitesh Chaudhary from Gamma Technologies to unfold the utilization of engine performance simulation. Having completed his master's in heat and power from COEP Technology University, Mr. Chaudhary has also worked with ARAI for more than a decade as a manager and later as a project engineer working on engine designing, manifold tuning, and thermodynamic simulations. Currently, he's working as a senior engineer at Gamma Technologies. Without further ado, let's start with this session. Over to you, sir.
Hello. Yeah, can you hear me, Yuvraj?
Yes, sir. Yes, sir.
Okay, yeah. Just a minute. Let me do some setting. I don't know. I think you asked me to use some background. Let me search that. Background, okay. Okay, yeah. Good to go. Okay, yeah.
Yes, sir.
Okay, yeah. Thanks, Yuvraj. So I have a couple of things before we start. Let me just pull out the screen. Yeah. So I hope now from hBAJA there are 8 teams, right, Yuvraj, currently?
We are 5.
5 teams. Okay.
Yeah,
So
Yuvraj,
can you just
yeah, Hitesh, I saw here. So there were 8 teams. Our 5 teams are currently present in the call. Yeah,
Okay.
3 others, as we said, they are yet to complete their some processes.
Okay,
So
okay,
5
great.
are in touch.
Okay. So can you just tell me which are the 5 those team members available? Let's say Prayan, College of Engineering, Pune is there.
Guys, you can just put hands up in the chat, or maybe you can unmute yourself and confirm also.
Yeah. So yeah, I will just read out the account name. College of Engineering, Pune. Team name is
Yes, sir.
Prayan.
Yes,
Available, right? Yeah, I
yes,
think
we are
it's
present.
Labesh, right?
Labesh, sir.
Yeah, Labesh. Okay, great. And then what is the current status? Now you received the dongle. That's what I see.
Yes,
Right?
yes, yes. Just
Okay.
received dongle.
Okay, great. And then what about installation done?
Not yet, sir. Not installation done.
Okay, yeah, great. Then there is a next team is College of Engineering, Trivandrum. Team Heracles Racing. Anyone is there? Okay. Next is Shao College of Engineering, Team Samskara. I can see, right? Team Samskara is there.
Yes, sir. Yes, sir.
Yeah, so I believe your installation is done, right?
Yes, sir. In process, sir.
Okay. Yeah. Then there is Kumar Guru College of Technology. Team Leeds Creek Racing. Okay. Then Devgiri Institute of Engineering, Aurangabad, Silver Fox.
Present, sir.
Okay. You have received the dongle, right?
Yes, sir.
Okay, great. In Cochin University of Science and Technology, Tarusa Motorsport. Okay, last is Vishnu Institute of Technology, Amigos. I believe, yeah, dongle is not received because I can see that you are, it is in the legal status.
Okay, sir.
Okay, so I think you should receive that.
Okay, sir. Thank
Yeah.
you, sir.
So only 4 members team I can see. COEP, Prayan, then Team Samskara, Devgiri Institute, and then Vishnu Institute of Technology. Who is the 5th one?
There is Cochin University of Science and
Cochin.
Technology. They have
Yeah.
messaged, they have received the dongles,
Okay, great.
but the installation is pending.
Okay, yeah. Maybe I will cover those things. I think there was some confusion at your end. So I will just show you what is this dongle, or how to do the installation, and what kind of support we will provide you, what are the resources available, and etc. All those things. Okay. So that's it. I think let's keep this session interactive. I don't want to only just present and then go. So today, Saurabh mentioned that if I can cover those points as well. So I will cover those. Okay. Great. Anything before we start from Yuvraj or Saurabh?
Nothing, Hitesh. Teams
Okay.
like we'll be having even more detailed session. So this will be mostly centric towards your phase 1 readiness and all these things to onboard you with the software.
Yeah,
So please
absolutely.
make a good use of it. Yeah. Thanks.
Okay, yeah, makes sense. Okay, and then what is I'm waiting from each team is that who are the members they have assigned, right, for this role. We are expecting minimum 2, but if you have less a member list, so if you can just help me, right, getting those members so we can enter those in our database.
Yeah, Yuvraj, maybe you can ask the team captain who will be responsible for this GT shoot, or maybe whether they first ask him whether they have selected those members or not. So the team captains, maybe you can unmute and maybe you can one by one tell. So Yuvraj, you can go one by one. Yeah.
From Team CVP, can you please unmute?
Yeah, Labesh. Yeah.
Yes, sir. Me and 2 of our members will be work on that.
Yeah. Can you give the name?
One name is Jashwin Ambire.
Jasmine.
Who is team member.
Can you
and
spell
one
Jasmine?
JASHWIN.
Okay, Jasmine. And who is second?
Means his surname is Ambire. So and second name is uh, Shubham Patil.
Shubham. Okay. Yeah, next.
Okay, Cochin University of Science and Technology. And someone unmute the mic.
Sir, including me.
Yeah, Labesh, I have taken it. Labesh Pawar, right? Correct. See, this doesn't mean that you have to limit to number 1, 2, or 3. It's like who is responsible, right, for at the end. So obviously the captain is there, but 2 members we are expecting. So you can do, if you are interested, every team, all team members can do the introduction training, etc. That's not a problem.
So, Team
Coaching.
Samskara, anyone from it?
Yeah.
Team Samskara. These teams, you can unmute your mic. This is an interactive session. This is done for you only.
At Devgiri Institute of Engineering. Is it okay if they switch on the video as well?
Yes, yes, yes.
So if anyone is sleeping, we can identify it easily. After lunch, it's difficult. Yeah, if you are okay, right, you can switch on your cameras, no problem. So as I mentioned, this is our first session, and then many more to come.
Yes.
Yeah.
Hello, sir. Am I audible?
Yeah.
Yes, sir. So
Right.
I'm Pranjal from Team Samskara.
Okay, yeah.
So for GT, we have installed the software, but still it has some errors while opening it.
Yeah, yeah. I'm going to cover those. Can you just give me names who are the responsible, right? Assigned members. For
Yes, it
GT.
will be one will be Tilak Chandan Khede,
Tilak, okay.
and another will be Amitabh Avasthi.
Amitabh, okay. These two, right, from your side?
Yes, yes, sir.
Okay, great. Thanks. Then, yeah, Silver Fox, Amigos.
Sir,
Yeah, Bhaskar, right?
this is Bhaskar from yes, sir, from Team Amigos. From our side, Rupesh
Okay.
and Sandeep and me.
Rupesh, Sandeep.
Yes, sir.
Okay. And Bhaskar, right?
Yes, sir.
Okay, great. Okay, then this one, Devgiri, Silver Fox.
Sir, it is Yash Bhakre here from Devgiri Institute of Engineering.
Yeah.
Sir, along with me, 2 other members are working on GT suit, Arbaz Khan, Nihal, and Abhijit Chavan.
Yash, Arbaz,
And Abhijit.
Abhijit. Okay.
Yes, sir.
Yeah, thanks. I think this one, coaching in Tarusa, no one is there, right? You mentioned
Hi, sir.
currently.
From Tarisa Motorsport.
Sorry?
I'm Jishnu from Tarisa. Can you hear
Okay.
me?
Yeah,
So,
here go.
need some connection issues. So, GT will be managed by Nihal and Abhijit.
Nihal and
Nihal and Abhijit.
Abhijit, right?
Yes, sir.
Okay, yeah. Yeah, thanks. Okay, so these are the things I wanted to know. Great. What else? Okay, great. So good to go. I don't know. So no one is switching on the camera. That's fine. Okay, so as I mentioned, right, today's session, I want to make it interactive. Yeah, thanks, Bhaskar. Thanks, Labesh. Yeah. Good, Anup. Thanks. Yeah, that's like I want to keep this interactive, and therefore it's not only one-sided presentation. I want to talk to you, understand your problem, and then accordingly how I can help you, right? Because this installation and everything, this legal process, as I mentioned, will take time because ours is a commercial license. It's not that academic version we have. So we don't want anything legal aspects from your side or from our side. So that's the reason it took some time, because there was some procedure. As I mentioned, you have to share those SLA documents, and our team shared with our US counterparts. They scan your accounts, everything, and then based on that, they give clearance. I think one is pending at this point, but it's good that, okay, at least now that procedure is done. And as I mentioned, like, this is going to take time. So it's good that many have completed this process. So today's agenda, let me share my screen. Share. I hope you can see my screen, right?
Yes, it's visible.
Okay, great. Just a minute. Okay, so let me just reiterate those things which I presented in our last discussion. So what is our offer, right, to BAJA team? Now, today I'm talking about the hBAJA. So as I mentioned, we are providing the software access, right, to the BAJA team GT suite. So this GT suite, as I mentioned, is used by OEMs, different companies all over the world. The same software you will be using. So we don't have the academic version. And therefore, all those capabilities which industry is using is there with you at this point. And then that's the plan that when we talk to Dr. Vora and his team, that you'll be using this for engine modeling, and then to start with baseline CNG modeling, and then we'll be converting that to HCNG first, and then 100% hydrogen. So that's a procedure you'll be doing on the physical engine. But being a simulation, right? It's you can anytime you can convert that to any kind of fuel. So it's CNG with different kinds of fuel blending, or it can be 100% hydrogen as well. No issues, right? We can always do that. So that's the reason we have allowed this GT suite access to all this hBAJA members. As I mentioned, you'll always point of contact for all these licensing related issues will be to Ashwini, and then you can always reach out to her. And then, as I mentioned, the communication should be from your official email ID. So, and whatever the communication we'll be doing is also through your to your official email IDs what we are. So please do check those email IDs regularly. If any communication, if you feel that okay is missing or required, you can always reach out to either Ashwini or maybe from SAE team members. Suman is there, who can always help you with those things. I believe now we have already sent the licenses to different teams except one, and then so this license is required, which is like 3 months. So every quarter we will send you. So what should be the procedure is that at least 15 days before you can send us the email reminder email ID that our license is getting over. So now, if I'm not wrong, till November you will have the access, but then every 3 months we will update based on the how is your progress. Are you really using it, or it is just for namesake? So based on that, we'll take the decision whether to extend or not. But at now, currently, till you are to 2024 BAJA, we will be supporting that. Okay, so that's the I think commitment from our side. Now, next important part. Okay, so once this is done, right? Okay, procedural part. What is important for you at the end user is that learning resources. Now, how you can get onboarded with GT platform, Gamma Technologies. So for that, we have let's say recorded GT suite introductory session. So what next I'm expecting, right, from all the captains is that you have to send us the name of those persons who will be doing this GT introduction session. So as I mentioned, it is not limited to only those 2 or 3 members. If let's say every team members is going to do that, we are okay with that. It's a recorded session. So we will just allow them the access. So for that, what you should do, right? You should send me the list, right? Who want to do the GT introductory session, which is a recorded part. Then once you send that, we will activate their access. But for that, you have to create your license on our website. So I'll just show you what is to be done. So if you go to Gamma Technologies, Wait a second. Yeah, I'm on VPN. Probably that's the reason. Okay, let it open. Should not take this much time. Anyway, so you have to go to our Gamma Technologies website, create the username password. This will take some time, at least 1 or 2 hours to get activated. And once that is done, you can send me the list, right? That those who want to do the GT introductory session part, and then we will activate their access, and then it will be a recorded session, so they can just complete that. Maybe we'll provide 2 weeks or 3 weeks window based on your interest. Then we have a lot of tutorials available and also webinars available. So that access you already have, right? Now the question, so yeah, before that maybe tutorials, which will be part of the GT installation, right? So you will have all the tutorials on different topics. So here you can go through the engine performance tutorial. Then we also have the examples and a lot of manuals available. So that's, I think that way onboarding will be very fast for you. And then you can easily get onboarded with our software. Yeah, now let me just show you that. So if you go to our Gamma Technologies side, we have this register button. Here you have to enter your email IDs and once this password, right? Once this is done, this will create account on our Gamma Technologies website and this is required for you to access our recorded session. I hope this is clear, right, to everyone. So you have to just go to our gammagtisoft.com and say the register. So those who wants this GT introduction access, just create your email ID password. And one important thing is that you should use your official email ID. Otherwise at Gmail, it will be auto filter and then you will not get this registration. So you should always use your college email ID. Okay, for this. So this is one-time procedure, and once this is done, you can then access a lot of resources which are available, blogs, podcast, then even within that, let's say recorded sessions, technical publications, etc. Okay. I hope this is clear. Now, next important thing is that download, right? That how to download this software. So as I mentioned, once you register with this email ID, in the resources, we have these download options, right? In downloads, when you go, those different versions. So I would recommend to download this 2023 version, and then this will be accessible once you have those login credentials. Then only you can see those download related links. And then you have to just download this software from our site. So let me just show you. So once you log in with your email ID and password, and now this download rights we will provide only to your captains, right? Or maybe your college professor who you can choose. So you can choose, right, to whom you want to give those download rights. And once you go to the downloads, you can see this GT installation version 2023. And then once you go here, installers, you can download this version 2023. Okay. Yeah, so you can download this file. And once you download this file, it's very easy that, okay, you have to just unzip this installer and start this exe file. And once you start the exe.exe file, at one point now you'll be asking, people are asking that, okay, what is the use of license file and what is the use of dongle file? So license file is required and dongle both are required. So dongle is basically physical hardware. All right. So what you can do now, question is that, okay, you have only one dongle, but you have, let's say, 2 licenses. We have provided 2 licenses to every team. So how 2 members can access? So our recommendation is that you can define your college PC, lab PC, or your professor laptop, not laptop, I would say, the workstation, right? Which is that you can declare that as a server. So this installation you can do. So once you start this installation, right, I'm going to show you what are the things you can do. So let me just show you what are the important steps here. As I mentioned, this is pretty straightforward. There is nothing you have to do. So now imagine you have downloaded this version 2023. All right, this one. So once you go inside this 2023, there is a setup underscore Windows, right? You have to just say run as administrator, and then my GT is already running, so I have to just close this before installation. Yeah. So let me start it again. Any questions, anything, right? You can just ask me meantime. But this is clear, right? At this till this point, two things I covered. One is the registration on our website for accessing GT introduction tutorials. Second, now I'm just showing the installation. For installation, you have to download the software. For downloading the software, you have to go to the resources downloads. But for this download, this page will be visible only to whom we provide the download access, right? So everyone will not see this page, right? For that, every team members, every team should tell us that, okay, who has the to whom we should provide the download access. Okay, once that is done, you have to just download the download this software and then run this exe, right? Then GT will ask you a few things. That is okay, fine, right? Now the question is, what do you want to do here? You want to define a college workstation, right, as a server. So you can define that as a server. What does that mean is that only it will be used only for the accessing the license. You need not to install GT software on the server, right? So it's only the license service. So you can uncheck everything. I hope this is visible, right? I'm not sure it's visible, but you can uncheck these things and only you can say that, okay, local license services, Flexilum. That's it. Okay. Now what it is going to do is that particular workstation, right, which has the internet connection, will be defined as a server. And now from the server, anyone can access the license, but at a time only two people can work, right? So let's say now you define this particular machine as a workstation, as a server. So only this Flexilum will be installed here, and then license file will be defined here. And then once you start this installation, it will ask you to plug in the hardware, that dongle. So that time you have to plug in the hardware. Okay, so it will say that automatically install a Flexilum license recommended. And then it will ask you, okay, so you can just keep it default, C drive, GTI, Flexilum, don't change anything here. And then now it will ask you, where is the license.file? Now here you have to provide that license.file, that file which we have given to you. Okay. So once you provide this license.dat file, now for timing, let me just select, yeah, this one. And then it will ask you, okay, what are those? So just keep it default, don't change anything till this point. And then once you start this next, it will start the installation. Okay. Now next part I will not do, but these are the two important things. One is that it will ask you for the license file. You have to just provide the license file, right? And then second, once you start this installation, at one point it will ask you to plug in that hardware dongle, what we call. So that dongle you have to plug in, that's it. And then your installation is done, right? So this is a procedure you should follow, right? And once this is done, now imagine you have your laptop, you want to access the GT software on your laptop. So the same procedure you will repeat here, but here instead of local license, you can say that, okay, GT suite version 2023. Now on that system, right, whatever, you have to select the GT suite, right? And then this PDF we have already provided to you, but if anyone has not received, please let us know. We can we can also provide you those instructions, steps, right, to follow. And then on your laptop, you can install now software where this minimum, I think 16 to 20 GB is required total space on your machine for installation. And once that is done, you have to, now it will ask you from where you want to create the, from where you want to access the license. So for that, then it will, what you have to do is, right, let's say create, you can just see that, okay, whether this to your laptop is connected to your server. So if you are in a college environment, you can access that, or let's say if you are at not in a college, so you have to then create a VPN, virtual private network, and then from that you can do, right? So if any issue, anything is there, just let us know, and then our IT team can help you with that. Okay. So I have instructed our IT team, if that anything is there, we can product, so we can help you with this. Okay. So it's well, I would say very simple procedure. Maybe it will look difficult for you, but only two things, right? One is declare your, this is our recommended method, because then in that case, two people can work simultaneously. Two can just access the, connect to the server and get the work, this license. Okay. Any doubt here? Anyone?
Uh, yes, sir. You said that if I want to access that in my laptop, means in my home, means if I am not in college, I have to do something that you said that
VPN, right?
VPN.
Yeah, it's
So,
VPN. So if you just talk to your college IT guys, right, admin, you have to tell them that, okay, how to create a VPN for this. It's like VPN is, right, it will allow you to connect to that server, right, college server from your home. At this point, whether you can access your college PCs from, let's say, for some reason, let's say now workstation or something, or any supercomputing facilities you have, anything. VPN should be a straightforward, right? So if you just talk to your college IT guys, they have to set up this VPN.
okay,
Yeah.
sir.
So VPN will allow you to access your college system, right, from your home.
Yes, sir.
Understood, right?
That will be fine.
Yeah,
Yes,
that's the reason I am telling you that, okay, then now not only you, the second person can also work from his home.
yes, sir. Fine.
Right? Otherwise, in second case, let's say now you don't want to do this. Maybe this is one-time setup. Maybe initially it will take time, but once this is done, it will be helpful for maybe your new team members as well. That, okay, once this is set.
Okay.
Okay. Because then two people can work at a time. Okay, not only two. Let's say now you have, let's say, 5 members who want to work on this system. So you can define, okay, that, okay, today I'm working in this slot, maybe 6 to 8. You can work from 8 to 10. So two people simultaneously can work, right, from home.
From home, yes, sir.
Got it, right?
Got it, got it.
Yeah. Anything else? Any other question? Anyone else facing?
Sir, at a time only one person can access it, sir.
Two. We have provided 2 licenses. So let's say now you're Bhaskar, right? So Bhaskar and then one more person you install on your laptop. So you two can access at a time. But let's say now third person wants to access, then he cannot access unless you stop using it. But he can install here works on his workstation GT, and then whenever is required, he can access that at a time too, right?
Okay.
Yeah.
Sir, for accessing that server should be on, means at
Yeah,
college.
obviously. Yeah. College PC should be on.
So what if, means college PC should be means they will get off after that 6 p.m. sir.
I don't know
What
how
on
to,
that
but yeah, you can request, right?
weekend?
Yeah, you can request that, okay, this is a like server we are declaring. I believe it should be there, right? It's not that only you are, but there should be some server, which not only workstation, if you have the server already, which is running 24/7, you can declare that.
Okay.
As I mentioned, there's no installation of the software, right? It's only the Flexalum.
Yes.
Yeah,
So
so there's
we
no
cannot
installation.
install
They
it
don't
on
require. Sorry?
our so that FlexLM we cannot install on our, means our laptops.
So
Means
yeah, so legally
we
you are
cannot
not
declare
allowed.
it as our server.
Yeah, it's like your machines we don't know. As I mentioned, right? This is what if, let's say, you misplace that or something like that. As I mentioned, the legal aspects, a lot of. And then as a student, you are not maybe after 1 year, if you won't be there, right, in a college. So those things, and then if you misplace the dongle or something like that. So those legal aspects why you want to go. So better you keep it with college and then you can access, right? It's like uh, very, very common practice, this VPN. It's not that, okay, something new. It's very common practice, and just talk to your college admin or maybe HOD, right? This is required.
Yes, sir. Yes, sir.
You're from COEP, right? I believe it
Yes,
should
sir.
be, yeah, they should have that. And it's like only declaring that as a server. So it's not going to, you are not going to install the software. So you don't require a huge space also. It's like few
Right.
MBs. That's it.
Yes, sir.
Correct. Yeah, but then VPN is nowadays very common, right? And especially after this COVID, now everyone, then otherwise that's how people access, right? During the COVID time, college PCs or office PCs, etc. through VPN only. It's not a big deal.
Yes, sir.
Yeah. Any other question? Okay, good. So I assume that till this point you are with me, and then main thing I talk about is the registration on our website. Once that is done, you will send me who should give, we provide the download rights, and second is to whom we should provide the GT introduction access, right? So once you provide that information, immediately will provide you that maybe for 2 weeks, 3 weeks, a 6 hours recording session, which will give you the idea about the GTs. Anyway, I'm going to show you those things, but it's better if you get your own time, right? Anytime you can just go run through those recorded sessions, etc. Okay, so my recommendation is to use version 2023, right? Build 1. So if you go here, and there is, let's say, sorry, this latest build 2 is also now available, August, right? So you can just install that, right click, say download, and you can install that after unzipping.
Yes, sir.
Yeah.
Sir, by what means we need to provide the data of the registered students?
By what?
Means we need to provide the data of the students who are working on the GT suite.
Yeah.
Through which means, I mean, through email, through any other means.
Yeah, through email. I don't know who is talking.
So yes, Bakre from team Silver Fox Racing.
Silver Fox, Devgiri. Yeah, just a minute. I will tell you who is your point of contact. Devgiri. Yeah, you are the contact person here. Yes. So email IDs are silverfoxsing sorry, Chetan Sagar
Sir, he is our
DIETMS.
coordinator.
Yeah. So ask him to send those details, right? Yeah. And if you
Yes,
have
sir,
your
sure.
college email ID, you can also add that. That's not a problem.
Yes, sir, sure.
Okay. So you can add them. Yeah, any other question?
Sir, am I audible?
Yeah, yeah.
So like just to confirm, like the college server will become the server for GT, and the license which will be running will be with the team.
No. You need not add it. That will be on the server itself. But
And so how must like how is the team supposed to access that?
through VPN, right? As I mentioned. That okay, you have to just
With
connect your
the
laptop to that server. That's it. It has to be just communication between these two. So once you declare that, so see, one is server and one is client, right? So your laptop will be client in this case. And when you do the first time installation workstation on your laptop, it will ask you where is the license. So you have to tell that, okay, the license is on this server, and in server there will be some IP address, right? For the server, you have to just provide the IP address. That's it. So it's like a one-time communication. Once that is done, you are ready to go.
Okay, so we will be able to access in like for within 2 PCs from the team.
At a time too, yeah. But let's say now you have 3-4 members who are interested, right? So you can install on for all 4 workstation, all 4 laptops. But at a time, 2 can work at a time, right? But let's say now you are not working, someone else wants to work, he can work that time. So at a time you can check out only 2 licenses, yeah.
Okay, so how are we supposed to make the college server as for the GT?
How to make what?
How to make the college server as a server for GT?
I was just showing, right? So once you start installing this, maybe we have this PDF as well. We can send you that. So
Yes.
let me just show you one more time. So there are two kinds of installation you will be doing. One is for server only, and second is for
Okay.
on your laptop. On a laptop, you will
Okay.
be installing the software, right?
Okay, sir.
And on server, you will be installing only Flexalum. So you'll uncheck this and you will see that only license Flexalum. That's it.
Okay. So this is to be done on the college server.
Yeah.
Okay, sir.
Okay.
Yes, sir. Thank you.
Yeah. Any other question? Yeah. So as I mentioned, this is first year, right? So therefore it is taking time. Once this is set, I think from next time you have to just update the license. That's it. License.dat file. Once this is done. Okay. Just a minute. Yeah.
Hello, sir.
Yes, just a minute. He's on a call.
Yeah. Sorry. Go ahead. Anyone has any question?
Yes, Yash had a question.
Yes. Go
Hello,
ahead.
sir.
Yeah.
Sir, how many students can register for the license?
For license, you need not to register, right? For introduction
No,
training,
sir,
you are
sir, for
asking?
accessing the license. Those who are working on the software. Those students.
No, I think you are getting confused. See, we have provided you license, right? We have provided you license.
Yes, sir.
Right. Right. Now it's up to you, right? How many students want to work on the GT? I believe there is like within team you divide, right? Let's say 2 members will be working on this, 2 members will be working on this, right? These 2-3 things. Correct?
Yes, sir.
Yeah. So let's say now minimum we want 2 because we have 2 licenses, right? We have provided. But if let's say 3 or 4 are interested, we are okay. You can just, because we have to provide you the introduction training access.
Yes,
I
sir.
hope
Yes,
this
sir.
is clear, right? Yes.
Yes, sir. That's the question I was asking, sir.
Yeah. So let's
Yes,
say
sir.
now 4 members are interested. See,
Yes, sir.
doing the introduction training using the software is like up to you. If you want to, let's say all members want to learn this, we are okay with that because we have to just provide you the introduction video session access, right? That's it. And already now, as I mentioned, at a time, 2 person can work at a time. But let's say now you want, if you do just divide, right? Okay, let's say now 2 will be working in this time, the other 2 will be working in that time. That's fine to learn with. Any other question? Yeah, I'll just show you what are those trainings. So that will give you an idea. Meantime, any other question, just let me know. I'll show you what training, right? What are the contents in training? So as I mentioned, this is the link we will be providing you. Once you click on that, it will ask the email ID and password. That's the reason you have to register here, right? So you can use your official email ID And once you create the password, now you can put those email ID and password, and then it will take you through all those recorded sessions, what we have. Yeah. So here you will get this access page, and then in part 1 GTC overview, so all those video sessions, right? Step by step, let's say. So this will take you all through this. Okay, and then there are different talks. So all this should recorded session is around 6 hours session. So this should not take every hour, every day. If you spend 1 hour, even if you repeat one more time, 2 weeks is more than sufficient. So that's the reason we provide the access for 2 weeks. This is clear, right? And for doing this, then you can, all team members can also do this. That's not a problem. It's up to you. Okay. And then there are training files also. So those training files you can just download from here, all those GT files which will be required you to start with. So those training files are available here, and then you will just download. So once you send me those communication, I will provide these details with you. Okay. So if you can provide me maybe by next week, right? They can also start with the introduction training as well. Okay, so these are the few things I thought of discussing with you before we directly jumping with all other maybe demo session. Any questions till now? As I mentioned, we have a lot of tutorials, not only on engine side, but cranktrain, thermal side, battery, then ball train, cranktrain, transmission, etc. So our commitment is for the engine performance, but it's up to you, right? If you have interest, you can just learn everything. That's not a problem. So as I mentioned, next steps, deadline, I think this is already done, this part, and then now installation. This took time from your side as well. There are some issues, but now sorted out. Now, as mentioned last time, VPN access, even let's say members, nominate, etc., completion of GT introduction training, etc. So this is done, and then I believe there are no questions at this point, right? So this is lesson now today's workshop. I would say current status from each team I have taken, resources I have mentioned. Now next important thing is the GT input sheet, which is let's say now in the month of September, right? You have this task to fill this GT input sheet. So everyone received this GT input sheet or not? We will provide you all those standard input sheet what we have. So let me just show you what is this input sheet. So now when you start with the engine modeling, right, these are the some guidelines we are given to you. What are the different input sheets? And now based on your preparation, right, individual team, I'm going to show you what is those input sheet, where it is required, etc. But then you will, it's like a geometrical inputs which are required for the engine modeling. Let's say now intake port, exhaust port, injector details, in-cylinder related details, crank train, wall timings, wall lip profiles, etc. Right. So all those details, there will be some inputs which are readily available. It's now bore and stroke, all other things. And then how you are going to fetch that data, right? Or how you are going to generate that data is, I think, depends on the individual team, how they are going to generate that. But we are there to help you if there is any question, right, related to one particular input sensor. So this I will share with you. Okay, this is an action item from my side. And then you have to, so as I mentioned, these are the guidelines, not necessarily that you will have all the data available to start with. But whatever data is available, now let's say dimensions out. So you can always measure those dimensions. If someone has, let's say, a scanner in their college, they can scan those components. That is also possible. So to give the more accuracy to those things, let's now cam train, wall train, system wall timings, they can measure manually, or they can just model it also, right, from the cam train. So that I think is very subjective, and maybe there are guidelines from our side how you can put those inputs, and then as I mentioned, I will provide you a starting example file which would be as common for all, and then from there I think the differences will start based on the individual team efforts, how they are going to put those efforts to in building those models. Okay. I believe now there's no compressor turbine, so no need to worry about that. So what is like say, irrelevant, you can just remove that, and you can put your remarks that okay, this is natural aspirated engine, so there's no compressor and turbine map, etc. But this is all those detailed list with you. Okay, so this I will share with you. Now, next important part is a modeling single cylinder SI engine. Okay, so let me go back to now GT and show you. Anyone has any question?
No, sir.
Yeah, good. So let me open this GT and I will take you through this modeling. Okay, so action item from my side is that GT input sheet. I will send it to you. Second, introduction training. I will provide the access. Third thing, once this is done, when you are comfortable with the GUI part of the GT, next is now engine modeling side. Okay, so now today I'm going to give you a basic overview that okay, what are the different things, right? What are the different components, templates, etc. But my plan is that we are going to record some sessions on the engine modeling, and then we'll share with each team members. Okay, so that will give you okay how to do that particular, let's say, engine modeling. It's already tutorials are available, but better if we provide some commentary while doing that, will be useful for you as well. So now, once you open, right? So what this is what we call a GTISE. So ISE stand from now GT is Gamma Technologies. ISE is Integrated Simulation Environment, and then version 2023 is our 2023 latest version. So every year we release three, I would say, builds in every version. So let's now version 2023 there will build 1, build 2, and build 3. So build 1 is already out, was there. Now build 2 is latest, is August we have released build 2. So if you are downloading, just download build 2, so that will have the latest features, etc. With the model. And then in the month of December or Jan we will have the build 3 model. Okay, so now version 2023, so this is our integrated simulation environment. Why we call this integrated? Because you can model everything within the same environment. So it can be, let's say, a conventional engine model, or let's say alternate fuel or hydrogen IC engine, CNG, or it can be, let's say, battery electric vehicle or fuel cell electric vehicle, or it can be, let's say, two-phase air conditioning system. So where there is a fluid and thermal, right? Everything you can model within the same environment. So once you open this GTISC, you can see this dashboard here where you can see this right side, some latest news which are there from our side. Just to add now, recently we acquired electric motor design company, which is called GT FIMAX. So our new products is already out, which will help you to model the electric motor modeling, etc. So all those latest news you can see here, and then in the resources, you will see different kinds of lesson now create, right? So when you say the new, you can create a different model, compound library. So once you go through that introduction part, I think this part will be clear to you. Within GT, as I mentioned, now this is a simulation software which has a pre-processing side, then solver side, and then post-processing side. So pre-processing nothing but the preparation of the model, right? So it can be, let's say, starting from the 3D CAD model, or it can be, let's say, simply starting with the template, etc. And then there is a solver part, basically numerical method side, and then there is a GT post. So once that is done, we have to post process the results. So we have this, let's say, GT post processing, GEM 3D, Cool 3D, GT Titan. But I think this part you need not to worry at this point, only GT post, right? And then we also have some utilities available, which are useful. Listen, or some fluid properties or default units, all those features. Next important thing could be examples, right? So, but I won't recommend you to directly start with examples. We'll come back to here later, but let's know tutorials. So I would say GT is known for their support and their documentation, right? A very detailed documentation on each and every domain. So within tutorials, we have different kinds of tutorials. I would say co-simulation, graphical applications, and modeling applications. Within modeling applications, then there are different topics: air conditioning, acoustics, after treatment, battery. Now, our interest today is let's say engine performance, right? So within engine performance, now there are 12 tutorials on different topics, but maybe interesting for you to start with is this one cylinder DI or SI engine. And then there is the one cylinder advanced topic, right? These two, and then the third is four cylinder, this SI combustion. So basically it's spark ignition based, right? So now here it's a CNG and HCNG and hydrogen, so all will be SI engine. But if you have interest, you can just go on and complete till I would say 7. This 8, 9, 10, 11, 12 are very, I would say, advanced and not recommended. But up to, let's say you have interest, right? You can complete up to turbocharging also. But what is useful for you for hBAJA or let's say this first, second, and third topic, third tutorial, right? So these are the .gtm. So our model comes this .gtm. So GT model is the extension is our model, right? Which model we are going to create. So these are the starting model for you in the tutorials or completed models, but all this documentation PDF is available here. So here is the PDF, and once you open that, all the documentation is there. So if you go to table of contents, we have basic single cylinder engine. That is the first, right? The first tutorial what we saw, this one. So SI final. So that PDF will start with that basic single cylinder, and then it will come with all those instructions, right? That resources, each step wise, how you can start modeling this. What is this? When you start, say that, okay, create new document, right? Create new GTM file. What are the steps you should follow, right? So, and then, as I mentioned, once you follow this, it's very detailed. And the same, I think we have provided you in the tutorials video also. So you, once you go through that, you will get acquainted with the GUI part, what is template, object, parts, etc. All those things. And then this will help you to understand what are the references, what are the different, let's say, dimensions, where to put, let's say now bore, stroke, diameter, inlet, length, all those templates will come. And as I mentioned, this is very detailed. It comes with those the template images as well, so it's easy for you to relate whatever you are doing, right? What are those inputs and everything. So this is tutorial number 1. So this will take care of the engine modeling, a single cylinder SI engine modeling. Now today my plan is that, okay, I will just show you those things so that you'll get some confidence, right? What are the things, steps? But as I mentioned, this is very detailed, already documented in our PDF, engine tutorial PDF. And once you, this should not take maximum, this should take maximum 1 or 2 days, right, to complete this first tutorial. So that's not a problem. And maybe initially it will take you time, but once you are, once you do this, right, 1 or 2 times, I think you will become expert in this. And then that's a chapter number 1. And then, as I mentioned, second tutorial is adding advanced features to the basic engine where you can create, let's say, parameter sweep, etc. But I will not go into details at this point. But I assume this PDF will help you, right, to get you onboarded easily for the engine modeling. Any questions till now? I hope you understood, right, where to access what. So if you go to file, there is tutorials. Within the tutorials, there are different segments. I would recommend you to start with engine performance, single cylinder SIF model, for which PDF is already available. Sometimes PDF won't be visible. Just make sure that, okay, you are not filter it out. So it has to be other. So then only it will show this PDF file, right? Just make sure then you are not filter it out. So this PDF will have all those 12 tutorials, stepwise instructions. Okay. On top of this tutorials, we have manuals. Now these manuals will talk about different domains. So if you go to the within manuals modeling applications, within that we have this something called engine performance. This manual will be very handy for you, right? Because then it talks about all those engine related stuff. So what is this in-cylinder flow, modeling cylinder walls, ports, fuel injection, what is friction related, what is, let's say, combustion. Within combustion, there are, let's say, non-predictive versus predictive combustion. What are those? So if you have interest, based on that, you can add those model in your let's say predictive or non-predictive combustion model, emission models, NOC. I would say they are advanced at this point. To start with, don't focus on the combustion modeling. Then maybe there are, but maybe once you are done with this first stage, initial level, maybe we can plan one session on purely on the combustion, where we'll talk about all those combustion models, right? What we have, what is this predicting combustion model, what is how to predict this NOx emissions, what is knocking, all those things maybe we can talk later. But this is very detailed, and then this will talk about, let's say now, what is the building and engine model, what is the data required, this fourth chapter, or what is the data required for modeling those engines, then correlating an engine model to a major data. This is very important, chapter number 6, part load engine modeling. But at this point, I would say this may be advanced for you. Now, as mentioned by Saurabh, that for next month, it is only limited to the input sheet, right? So based on your preparation, you should focus on those generating those inputs, right, for engine modeling. Okay, but the material I'm mentioning because then you at some point that, okay, you'll say that, okay, I'm done with this part, what extra I can do. So you can always go through those manuals, examples, tutorials, which may be useful. And then you just try to see that, okay, what are the things you can involve in your modeling. Okay. Any question anyone has till this point? Okay, great. So let me get started with modeling question. So once after this file, then if you go to the home, I think this is very common, right? If you are using Windows, Excel, PowerPoint, this dashboard, this templates, features, etc., is you can easily relate. That's not a problem. So when you say the file, new file, right? So listen now, I want to create a new file. So I can say new file. So once you say the new, it will ask you what you want to create. So obviously at this point only GTM file .gtm. Say next. Within that GT power, then what license we are going to use. Now we have provided you GT. I'm not wrong, GT power or GT suite, but for your use case it is GT power. So you can let it be GT suite. That's not a problem. But then in that case, it will load all the libraries which are available in the system, right? From all the domain, aerospace, air conditioning, cooling system, cranking. That's not a problem. It's like we can always filter those. But if you just stick to GT power, it will load only those engine performance related, after main and aerospace related, right? Libraries. So at this point, I will say GT power and I will say finish. So once you say this finish, it will open, it will have those window right here where you can start modeling. And how you can start is that we have this template library. Yeah. So once you go to the template library, this is like collection of all the libraries, right, which are there in the GT. As I mentioned, it is like an integrated simulation environment. So all those template library, if you see, we have from different domain lists, flow, mechanical, thermal, electromagnetic, control, acoustics, external, general. So based on our requirement, you can always go to that particular model, general flow, components. Within components now, let's say if I want to create a cylinder, right, engine cylinder, I can go here, search, let's say cylinder. And then from here, you can just pull this, right? So just observe out. Now, when you pull this, it will ask you what is the object name, right? So this is, let's say, engine cylinder, and then it will ask this, it will come with this warnings that, okay, this warning means what? Some data is missing at this point. So there are a lot of blanks, right? This initial state object, oil temperature, heat transfer, flow object, right? And then individually, we have to go to the value selector and select this fluid cylinder object, etc. Right? And then it will again ask you some object name. Let's say now some ABC. So now what you can see is that it has created. Now there are two libraries you can see out. One is the template library, which is, let's say, what we have. And now here, this is a model library. Here, this left side model library, you will see that, okay, what are the components, templates you are going to add, it will be accumulated here, right? So at this point, I have added engine cylinder template. Within that, I have created the object, and this is a part. So what is this part is that I can just copy and paste it here, and it will create one more part. Now, why I'm going fast is that, as I mentioned, this is already covered in the in very detailed manner in the tutorial as well as in the recorded session. So that is going to help you. But now I'm just taking you, giving you a bird view, because what do you say that what should be the right modeling approach? Now, I'm very sure what I'm explaining is you will not understand anything, right? And that's the reason I'm taking this approach that, okay, I'm starting from the, let's say, very basic template library, and then from the left side, there are a lot of templates available. From that, now which one to select? So this is the approach I would recommend not to use. And therefore, I just showed you, right? Because you have understood nothing, the approach I have used, where you will not, as a, if I'm, because let's say I have spent maybe last 10 years on this software, so I can easily go to the different time. I know what should be the right strategy. But now when someone is starting, right, I would always recommend not to use this approach where you will not start from the scratch, but you will start from our tutorials. So now imagine your task is to create a single cylinder SI model, right? So I would recommend use this approach where you'll start from your tutorial or example file. So readily templates or readily these models are available, right? And then now what is interesting with this approach is that now you are already, you can see that, okay, already this single cylinder engine model is in front of you. Now you can go to the individual template and try to understand how this particular thing, how they have defined a wall train, how they are defined a injection system, how they are defined a port, how they are defined a runner, how we have defined the engine crank train system, right? Wall timings, all those things, in-cylinder combustion. So one by one, you can start. So the other approach which I was showing is definitely once you are expert, right, you can always use this approach where you'll start from the scratch and then you will go with the individual template. The other method which I would recommend you to start with this tutorial, right? And then that's how we want to build, right? We want to create a single cylinder CNG model at this point, right? And the first assignment for you is to create those input sheet, right? And that's why I think in the month of September, you have that review for the GT input sheet. So now what I would recommend you to do is go to our tutorial, first single cylinder SI engine model, and now just scan this, right? Individual components. So let me now go back and now see this cylinder, right? Here's cylinder, and this is the model library. So in the left side, you will see that, okay, what are the templates used in that particular model? So if you go here, we can see that this is cylinder one, right? So always you can say that, okay, right click and say that find in tree. So you can directly find it here, or if you just click on that particular part, it will directly highlight here. So if I just go to runner and just highlight here, it will directly highlight, okay, this particular intake runner or intake port, right? So this is how when you have, let's say, multi-cylinder model, it can be very huge, and then you cannot understand this. So better you can, as I mentioned, start with the tutorial one, single cylinder SI engine model, and then one by one you can go to the individual templates. So now let's know this cylinder. But before that, what I wanted to highlight is that now what is this structure, right? So if I show it here. So this is a engine cylinder, cylinder and cylinder one. These are the three things you can see here. So cylinder one is this part. The top level is object and engine cylinder is a template. So now engine, so what we call as a template, object and part. So you can create different parts from the single object. So as I mentioned, now if I want to create this 6-cylinder engine, so I will just copy this 6-cylinder cylinder one 6 times, right? So now you can observe here. Now you can see only one part here, but if I copy and paste it here, GT will automatically create one more part, right? So now this part, cylinder 2, will have all the properties of this object cylinder. So if I just go here inside, already these values will be pre-filled. This initial, all those details, right, will be taken from this particular part. Got it? So once you create one particular part, it is easy for you to copy it multiple. But here we need not to worry because our model is only single cylinder. So we need not to create different parts. But just additional information I wanted to provide you here. Okay. And as I mentioned, this already mentioned in detail in the video tutorials and in the PDF. So that will, once you go through that, that will help you to understand that, okay, what should be the modeling steps when we create. Now coming back to the input sheet, let me go back to that input sheet here. And now you can see, right, a lot of things I have mentioned. Let's take example of now let's say this wall timings, etc. What is wall diameter, lip profile, gesture? So let me explain you this. Any questions till now? Anyone? Okay, great. So let's get started with wall timings, right? So can you tell me what are the different components engine will have? Let's say now air filter, right? What else? Intake port. Then what?
Cylinder,
Cylinder, good.
exhaust port,
Exhaust, good. Exhaust port.
spark,
Then spark plug,
spark plug,
carburetor. Okay. Then whether this engine has carburetor or injector?
out of the window, outside window.
Sorry,
Outside the engine, sir.
there is a injector, right?
In this injector, sir, for CNG. It's a
Okay, CNG
bifuel
injectors, right?
actually. Yeah, sir. It's a
Okay.
bifuel. It will be both.
Okay.
It's by
Okay. What else? Yeah. What else? Within cylinder, what are the important things? Let's say now if I talk about the intake cylinder, sorry, this cylinder, right? Engine cylinder. What are the things which are important? What kind of physics which are important in the cylinder?
and bore stroke.
Okay, those are, let's say, geometrical inputs, right? Bore, stroke, let's say compression ratio. Then what else? These are, let's say, geometrical related, but let's say what kind of physics? Now, one kind of physics is combustion, in cylinder combustion, right? So that's a physics. So where the fuel gets converted, so chemical energy gets converted into a energy, right?
Yes.
So that's the one physics. What else? What is the second physics, which is important? Heat transfer.
Yes, heat transfer.
Right? Yeah, because that cylinder needs cooling. So it can be, let's say, air cooled or liquid cooled. So this engine, I believe, is air cooled, right?
Yes, sir, air cooled.
Okay, yeah. So air cooled, and therefore that is going to decide the temperatures, right? So when it comes to physics, what is important in the cylinder is, as I mentioned, the combustion. At what rate the fuel energy is getting released to a energy. So can you tell me what principle this is? Let's say Otto principle or diesel CI principle. This is Otto, right? Otto cycle, correct?
Yes, sir.
Yeah. So in cylinder. So when there's a spark plug, what is going to happen is that a lot of energy is getting released during that stroke. So if you have the PV diagram, so it's like a constant volume heat release, right? Theoretically, but obviously it is not going to be exactly like this. So that kind of things we should able to capture, and then that will decide that, okay, what is the MFB50? Now, what is the MFB50? Can you just explain me? Let's say there is a burn rate, right? But if you have the cumulative burn rate, so I would recommend if you are not read any IC engine book, just read that, right? It can be Ganeshan or it can be, there are so many, Haywood also, there are good books that will give clear understanding about all those physics which are important, because many times people ask me, right, how easy it is to learn GT software. I always say that it's very easy because this should not take more than a 1 week, but this is GUI part, right? And these are the analysis software. These are not CAD software. So you require some engineering knowledge at the back end, right? You should know what is heat release, what is combustion, what is let's say what is those injection, right? And then how it is going to impact the performance, because faster the burning happens, faster the heat is getting released, and therefore it's good for those performance. So how to measure the performance of engine? Can you tell me some parameters for engine? How you say that, okay, engine is good or bad?
Torque, power.
Okay, good. Torque, power. What is?
BSFC.
Okay. Only Labesh is answering. What about others?
Consumption of fuel.
Okay, good.
That's
Fuel
for
consumption. What else? BSFC, right? What we call brake specific fuel
BSFC.
consumption. Okay, good. What else? How you will say that, okay, how, let's say now if I give it one engine to you, right? And now ask you, okay, do the analysis for that thermodynamic analysis. You are doing the GT power analysis. That is true. That is true. But then what are the things you are going to check there? As I mentioned, torque, power, right? But then what is important is the brake mean effective pressure, right? BMEP. That is very important. What are the other terminologies? Airfill ratio,
Yes.
lambda, correct?
Yes.
What else?
Lambda.
BSFC, you talk about, that is correct. Then how much is the heat load, right? Heat wastage through exhaust, through cooling. Okay. What else? Volumetric efficiency, correct? Volumetric
Yes.
efficiency of an engine. What else? How fast there is a sorry?
Indicated power and brake power.
Okay, yeah, brake power, yeah, correct. Indicated mean effective pressure. So all those, even let's say what is next important is the pumping losses, right? PMAP. Then what else? How much residual fraction is there, right, in an engine? What else? Pumping losses, PMAP, pumping losses. That's very important. Gas exchange process. What else? Exhaust temperatures, are they important?
Yes.
Yeah, how it's important? Exhaust temperature, what it is going to tell about um,
Heat
your
loss.
engine. Correct, heat loss. What else it will tell you? It will tell you, okay, what lambda it is operating, right?
Yes.
Imagine now when you go to the visit a doctor, or when you go to the, right, and what they do our testing, right? Basic testing. And those parameters will tell you about your health, correct? Similarly, when in engine, when you do the analysis, there are so many terminologies which is going to tell about those engine performance, and not only performance, but whether that is good or bad. Whether, let's say now exhaust temperatures are very high, is it good?
No, sir.
Yeah,
No.
but yeah, it's good that, okay, if you go to hard, but then you have to always ensure that it is within the safe limit, right?
Yes.
And then to operate to the safe limit, then you will go back, okay, why the temperatures are very high? Is it problem with the airfill ratio? Whether airflow rate is too low, why it is low, whether it is because of the volumetric efficiency, so whether I should improve the volumetric efficiency, right? So those things. So let's say now how industry is using our software right now. Imagine a lot of now discussion is a hot topic is hydrogen, right? So hydrogen is one of the hot topic nowadays, and companies like now let's say Cummins or Ashok Leyland or Mahindra or Tata Motors, Volvo, or I'm just talking about Indian company, but there are so many companies all around the world, right, who are using our software. So how they use our software that okay now they have this basically how hydrogen engines are developed right nowadays that they have the base diesel engine which is available with them, correct? And then now that diesel engine, they want to convert to a hydrogen IC engine. So can you tell me what kind of challenges they will face that, okay, now imagine when they are using GT power, right? What assignment they get that, okay, this is the base engine, diesel engine. They have to convert that to hydrogen IC engine. And these are the target performance. Target performance are like, let's say now torque, PMAP, also emission, right? Emission limits, not only steady state, but emission, transient emission limit. Let's say now PS6, now Euro 7, there's a discussion, right? So when you do as a, let's say, thermodynamic engineer, right? Or maybe when you are using a simulation software like a GT Power, what is your role there? So your role would be that, okay, now you will do a base diesel engine model, which is well validated, right? And now you have to convert that to hydrogen IC engine. So what are the things you will do? Can you tell me what are the things now you will do to convert diesel engine to a hydrogen IC engine? What challenges you would face? They should, okay, like not necessarily it has to be correct. What is the basic thing we are going to hear? Diesel conversion of diesel to hydrogen IC engine. We are converting a CI engine to SI engine, right? Diesel works on the CI principle, compression ignition principle, and hydrogen works on SI principle. Can you tell me why there is a hydrogen works on SI principle and why not on CI principle? Why we required a spark plug and why we not use compression principle to burn a hydrogen?
Higher calorific value.
Higher calorific value, okay. Then
It's
It will
ignition
be difficult to spray
lowest.
them.
It requires lowest ignition.
okay,
Uh,
yeah, Bhaskar, you were telling something.
It will be in the form of gas, and then actually the diesel engine, we have to spray the fuel.
Okay,
When come to the hydrogen, it will be difficult to maintain the high pressure.
okay,
To it.
okay, great, good. Have you heard about octane number and cetane number?
yes,
Yes, sir.
Okay, what is the, let's say, can you tell me octane number of diesel?
it's less than gasoline. Sorry.
It's what? Whether diesel has octane number?
No, sir.
No?
Means less. It
Okay,
has less of the
okay,
number.
good. So every fuel has its octane number and cetane number, right? Every fuel. So if you take the octane number of diesel, it will be very low. And if you take the cetane number of gasoline, it will be also very low. So what does that
Yes.
mean? That okay. So cetane and octane talks about the how fast or how slow the fuel will burn. Correct? Higher the cetane number means that okay, fuel will burn slowly, and higher the octane number means what? Fuel will burn very fast. Okay, and therefore it's very important that what kind of fuel we are going to use. Now hydrogen, if you talk, it has a higher octane number, so it has to be SI principle. Okay,
Yes.
and therefore I would recommend you when you want to really make use of this software, right? GT Power, definitely GUI is one part which you will learn within a week time when you go through that tutorials and session, recorded session. But these things will definitely come when you go back and read those IC engine basics, right? If you go back to Haywood and run, read that, or there are few, as I mentioned, Ganeshan, or there are so many, right? I remember because I use those and during my engineering days. So go back and just read this. What is SI principle? What are those things? And what are the different parameters? Because now when you start doing this, it's not only about those running, right? Creating the model and running it. How to make you, because now you are going to compare that with your real engine. Now this Graves engine, single cylinder engine, which is a CNG engine, right? Which you are using. But earlier it was not CNG, it was
Petrol,
diesel engine. It was diesel
yeah,
engine, then converted to
petrol,
CNG engine. I don't know what is the best this petrol engine converted to
petrol
CNG.
engine,
Okay,
petrol
great.
engine converted to CNG,
Okay,
bifuel
great. Okay, great. So that's a great thing. So petrol engine already converted to CNG engine, and now you want to convert that to HCNG engine. HCNG first, and then maybe a 100% hydrogen. So when you do this, there are some modifications required, and why those modifications are required is very important for you. So those things you will understand. And now, can you tell me one challenge which you will face? Let's say now this engine is CNG, and then you are converting that to 100% hydrogen. What one major challenge you will face?
injection system and ignition timing. Yeah,
Okay, injection system. What is?
ignition timing.
Okay, what is?
Knocking occurs.
Knocking. Okay, what is? What about, let's say, volumetric efficiency?
Yes, volumetric.
Okay, but then how it is going to impact, right? CNG versus hydrogen. How it would be challenging? Can you tell me? And why?
In volumetric efficiency, we- which is directly related to air fuel ratio. Yes.
True, but then yeah, you're close. But why this air fuel ratio is important? CNG versus hydrogen.
That means air fuel ratio is important for that mileage for means PSFC.
Okay, have you heard about stoichiometric air fuel ratio?
Stoichiometric air
So what is
fuel
the stoichiometric air fuel ratio for CNG versus hydrogen?
17
And for hydrogen?
for, for hydrogen it's very mm, far more than all that.
Around 32, right? Exactly.
32
32, yeah.
32 right sir,
So
32.
now imagine now when 1 kg, sorry, when 17.2 kg of air was available, you could burn 1 kg of CNG. Right?
Yes,
That's the meaning, right? Lambda equal to 1, exactly
yes,
stoichiometric air fuel ratio. But
yes,
now this engine is your natural aspirated engine, right? So air is not going to change even if you add hydrogen. Air will be same.
yes,
But now because of this hydrogen problem, hydrogen requires 32 times, right? So
mm,
almost double of air to burn same amount of fuel.
yes sir.
So it's going to be challenging, right? So that challenge, how you are going to handle that? So those things you can do analysis using a software, right? That okay, now if I replace this CNG with 100% hydrogen, whether I'll get the same performance? If not, then how I can compensate that, etc. Whether wall timings can be changed or any supercharging is required. So those things you can easily do with using the simulation. And therefore, what is important for you, as I mentioned, is that GUI part, which already, as I mentioned, recorded session tutorials will take care of those things. But now second important thing, analysis, right? What exactly you are doing using this software. As I mentioned, now industry use this, let's say now converting hydro to hydrogen engine, and therefore they will face this problem. Okay, diesel had this amount of air, but now because of hydrogen, I have to run it very lean at very high lambda, and therefore I'll require more air. So this turbocharger I should change. So now this turbocharger was, let's say, single stage. I will require two-stage turbocharging, or I will require variable geometry turbine. So those decisions they can take there, right? And they can do the selection of the turbocharger. And when they will build a hydrogen engine, they are now aware, okay, what turbocharger system they should use. So those things they can do analysis there, right? And within the hydrogen, whether it has to be a direct injection versus port injection, those things we can easily understand. I hope this is clear, right? So why I'm telling this is that you should do analysis using the software. This part I think will not take you more than a week or 2 weeks time to build this model, because as I mentioned, you can start with our example model and now you start changing this rate right now. This intake runner, you can go to your engine, just measure that dimensions, what is the length, what is the diameter, change this value from, let's say now this is 40 mm and length was 350 mm, yours is let's say 50 mm and length is 200 300 mm, you'll replace that. That is okay. Intake port is okay. Intake wall, now these are the wall lip profiles, right? For your engine, this wall timings may be different, and accordingly you will change those values here. There's, instead of let's say wall lash 0.1, if the wall lash is 0.1 for 0.2, you will change this value very easily, flow coefficients, right? And then the question now here is the difference, right? So as I mentioned, we will provide you some initial model to start with. Tutorial is always there, but let's say now for Greaves, what are the engine? So we'll put those dimensions, we'll put this, and with very basic model, we can provide you that details with you. Now, how it is going to differentiate from different teams, right? And now team one can go into all those wall timing details and they can generate a good amount of data, flow coefficients. Now this flow coefficients, you can create a 3D CAD model and maybe you can do a testing or you can do a CFD analysis of that. You can generate that flow coefficients. That is also possible, right? So when I say the input sheet, what are the templates, right, we are going to use, and then what are the inputs related to that? Now, let's say this intake runner, geometrical inputs are very clear to you, right? You know what is bore, stroke. So if you go to our engine crankchain template, here you can see the cylinder geometry, and then within geometry, what is a bore, stroke, conrod length, compression ratio, TDC clearance height, etc. All those details. And anytime if you feel that okay, you are not aware of the what is this particular input, you can just click on that particular attribute and then click on the help. So directly template help will take you to that particular lesson of what is compression ratio, the ratio of, so all those understanding, and then what should be the default value, right? All those details are readily available for you in individual help. So that's not a problem. Got it? Now firing order. Now here it's being a single cylinder, there is no firing order. It's always one cylinder, right? But you imagine if it is a 6-cylinder engine. So 6-cylinder engine will have the firing interval of 120 degree each. So it can be 1, 3, 6, 2, 4, whatever. And then you can easily define those portions here. So geometrical inputs, I don't think so you will face any challenge. Now the next challenge could be once you run this model out. Now when you go to the case setup, you can define, let's say, max power, max torque condition, different RPM. And once that is done, you will have the post processing of that, right? So let me just run this 3600 RPM case. Now this engine is running at 3600 RPM. What is the max speed of your engine? This, what are the engine you are building? Rated RPM, 2800 RPM, right? Or
Yes,
3000? 2800 RPM. Okay, good.
yes.
And what is the max torque? Max
Yes.
torque of your engine? CNG engine? Anyone has those details for your engine, base engine?
Yes, sir, I have.
Okay, can you just tell me what is the bore, stroke?
Sir, just a minute.
Yeah.
Yes, sir.
Tell me.
That bore is 86 mm.
Okay.
Stroke is 68 mm.
Okay.
Connecting rod is 117 mm.
Okay, good. So all those details are available with everyone, right?
Yes, sir, it is available in that manual given by Agri.
Okay, great. 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 Okay. And what about the max power, max torque?
That rated power is 7.25 kilowatt at 3400 RPM, and maximum torque is at means is between 1600 rpm to 2400 rpm, which is near a flat curve.
What is the torque value?
24.5 Newton meter.
Okay, great. Yeah. So the first task could be to, as I mentioned, generating all those required input details, and after once that is done, you can run, or maybe you can start with what are the known, and where the inputs are not available, you can keep those default values which are available in the example tutorial values and just go ahead with that. Okay, and
Yes,
just see what is the gap, because when you start day one, everything will not match exactly. Right, as I mentioned, those power
sir.
torque values exactly will not match, but you can accept some error, maybe 5%, 10%, and then you can go ahead with everything, right? Where you can. So now imagine, let me just do this. So file, save as, okay. So now let me just quickly change. 86 is the bore, right? And stroke is 68, you mentioned, right? And
Yes, sir.
117 is the Conrod
Yes, sir.
length.
112, sir. Sorry.
112. And what
112.
about the compression ratio?
9.5 M.
9.5. Great. And then all these values I'm not changing. What could be the interesting here is the RPM. So RPM you mentioned one is 3400, right? And second is it's 1400, sorry, 2400, right? Max torque.
Max torque is at 2400, means which is with near about flat torque. They given that 1600 rpm.
1600 till 2400 RPM. So let
Uh,
me just add 1600 as well. Okay. And this engine is not gasoline, right? So
yes.
now if you see this, let me just explain this. This is an environment, so basically ambient air which is going to the intake runner. Then from runner it goes to intake port, then intake valve, then cylinder, exhaust valve, exhaust port, exhaust runner, and ambient. And then there is this injector which injects that particular fuel, right? So
Yes.
this fuel is, if you go here, this is indolene, but we want this CNG, right? So what we can do is we can instead of it has to be CNG, right? So we have the example available for CNG.
Can we add methane?
Yeah, we can add methane, but I'll just show you how to add that, right? So we have this natural gas, SI natural gas. This example is already available. I'm just telling you how you can make use of those ready-made tutorials, examples available for easy understanding. This is the approach, right? I would recommend you to start with. And once you get this good understanding, you can always change those. So this is the CNG which we are injecting here, and this is the composition as a natural gas, right? So these are the things. So now in GT, you will see that particular now how, as I mentioned, this is the boundary pressure template. Within the boundary pressure template, E301 is the object and this is the part which is created, right? And within that composition, we are defined as a natural gas. So you'll see these three dots. So these three dots, then you have to select the natural. But natural gas is a combination of CH4, propane, either, right? So that combination changes. So what we do instead of using a directly natural gas, we can use this fluid mixture combine, right? A reference object and this natural gas. But now here what we can easily do is that we can search because it's already available in this particular model library. So you can just say right click and say copy. You can come to your model and just say paste here, right? So it will be pasted in this, right? So now you will see that it has created the fluid mixture combine part natural gas and automatically it has added ethane, methane and propane, right? Which is from this example model. Got it? Yeah.
Yes,
So yeah, no need to worry. I think as I mentioned, we are going to record this and we are going to send this, right? How to convert a gasoline engine to a CNG engine, etc. Now easily what I can do is I can go here. Now this particular reference is available, natural gas. So instead of Indolene, I will just select here directly natural gas, right? Because it is directly available here. Now this natural gas, I can see that methane is 88%, ethane is 6%, propane is 6%. This distribution you can easily change. Now if you, let's say your particular fuel, methane has 92%, another 244%. So you can just change this. Okay. And I'm going to inject this CNG into the system, right, in the intake port, and then there are 3 RPM, right? Now see how quickly I have built this model. I have not done any changes. I have not changed any wall timing, wall profiles, etc. because I'm just sticking to the what are the tutorials available. And now let me just run this. Oh, sorry. I think we missed to change the lambda value. Now this is not 14.5, right? It has to be 17.2.
17.2.
Okay. So let me just stop this. Anyway, by the time is already run all 3 cases. Yeah. The differentiation will happen based on how particular team generates that particular inputs, right? And then that is going to define the accuracy of your model, because how close you go to your physical engine. You are going to replicate that physical engine, right? That cruise CNG engine, your GT model. So deviations will have impact on your performance, etc. So let me just show you the results. Now, if I go to this particular HCNG report tables, GT posts, no need to worry. As I mentioned, this will be clear in your tutorials. But let's say combined table data. Now, these 3 speeds I run and engine cylinder, I want to see the performance, right? So both gets it. Now 3400 RPM, I want to see power, right? So I'm getting 9.4 kilowatt here, right? How much you mentioned your engine has?
7.25.
7.25. Max torque, I'm getting 25.5 Newton meter, 24.4 Newton meter. How much you mentioned?
24.5 Newton meter.
Okay, so we are already close here. Now, can you tell me why I'm getting 9.4 kilowatt and that particular engine is limited to 7.25 kilowatt? Can you guess what could be the reason? So now here, see, I have not touched volumetric efficiency part. I have not touched wall timings, wall lip profiles, all those teams. I have not touched, right? Because as I mentioned, now at that I leave it to individual teams. I don't want to give everything as a spoon feeding, but I'm telling you the approach you can use it. So once you are comfortable with the GUI part, once you are comfortable with tutorials, all those things, right? That will make sense. Okay, now what are the things I should see here? Because as I mentioned, GT gives a lot of information. It provides you everything, right? It provides you all the parameters, all the plots. But now question is what you are going to do with that? How you are going to do the analysis? Let's say now it gives you incident pressures data, it gives you burn rate, it gives you PV diagram, etc. It gives you MFB50, PSFC, airflow rate, BMAP, PMAP, friction side. How to read those? It gives you brake efficiency, airfill ratios, all those things, right? All those stuffs are lot of information is available. Now question is how you are going to use that particular information is very important. Yeah, so my question was, can you tell me why this is 9.4 kilowatt? What could be the reason that, okay, my torque is matching well with this engine, but if you see the brake power, it is 9.4 kilowatt versus what Labhesh is mentioned is 7.25 kilowatt, right? It is on the lower side.
Sir, we considered means ideal cases that we didn't consider that internal frictions and all that things. So that's why I'm just guessing.
Okay, yeah, friction could be off. Okay, good. Second reason. The volumetric efficiency could be on lower side in real engine. It's not 70, it's now showing 74.9. It may be lower than that, right?
Yes.
Third important reason could be, can you guess?
Wall times.
Ball timings, okay, good. What else? How this lambda is important? Tell me now, when the engine is running at full power, right? Whether lambda is important there, and then in real case, whether it will be reach or it will be lean. What is going to make the difference, reach versus lean?
That reach will give more power.
Reach will give more power?
Means fuel air ratio. I'm not talking about air fuel ratio. Rich fuel.
Reach will give you more power, you mentioned. Rich mixture.
Means fuel is more than air. Okay.
The fuel is more than air, that's what we call as the rich mixture, right?
Yes, sir.
But rich mixture will increase your power or reduce your power? Any guesses? And this is very realistic. Yeah? This is how it happens when you start tuning your engine, right? Real engine. This is a very big challenge. Is going to happen is at the rated power, rated. So reach will make it, will provide more power. Let me just go back, right? Let's go to the GT. And what we will do is, let me define this as a parameter instead of defining. Now let's say what I want to do is I want to define this as a parameter 17.2. So I will say that, okay, air fuel ratio as a parameter, right? And it will ask you, okay, what should be the value? So let's say now let's say I want to repeat this case. I'll say insert one more case here, and instead of 17.2, or let me add one more insert case. So let's say now one is lower air fuel ratio, let's say 16. This is 17.2, and let's say this is 18. Okay, so 16 is rich, 17.2 is exactly lambda 1, and this is lean mixture, right? Let me deactivate these two cases. Okay, three cases, let me run. Now you have seen, right, how this adding these parameters is helpful for me. I can easily add three cases. I have not changed. I have changed. I wanted to change only this air fuel ratio for all three cases. Therefore, I created parameter. How to create a parameter? Just add the square bracket, and you can name anything. You can say air fuel ratio. You can say lambda, anything, right? Or if you don't want to put anything, you can say right click and say create a parameter, and then GT will automatically create that particular parameter with them. But now here I have created three cases running at the same RPM. Only difference is now air fuel ratio. Okay, so let me run these three cases. So now I want to see what is going to happen with my lambda, right? Any guesses what will happen with the rich mixture?
It reduces power, sir. When
Okay,
it comes to the
why?
lean mixture, it may increase the power, sir.
Okay, so why reach will reduce the power? Can you tell me? Is there any reason?
In rich mixture, fuel will be significantly burned.
Sorry?
In rich mixture, fuel was insufficiently burned. It will be partly burned, and lean mixture, it will be
Okay.
fully burned.
Okay, good. So let me not answer this at this point. Do one thing. Maybe when we will be meeting next time, right? I would recommend you to just read any basic IC engine book and just see why this range or lean is done, right? And maybe I'll just give you a reason. Okay. What happens when the engine is running at high power, and then when the engine is running at that exactly stoichiometric air fuel ratio, the exhaust temperature goes very high.
Yes, sir.
And when the exhaust temperature goes very high, it's like it goes beyond its limit, and therefore you have to reduce those exhaust temperatures. So what we do is we purposely make it reach. So making it rich, what happens? The combustion efficiency goes down because now, see, what is required for burning of fuel? What is important?
Air means
Air,
oxygen.
oxygen, right? So if air is not there, fuel will straight away come out as an emission, pollutant. So if there is no, now imagine if you are putting more fuel than the
Incomplete.
air. So there's incomplete combustion. The combustion will not happen because there is no oxygen available. CH4 required, hydrocarbon requires oxygen to burn. And there is no burning, and therefore it comes out as a what? As a pollutant, right?
Yes.
And therefore, just to highlight here, brake efficiency in this case 1 will come down 31.6 because what is the brake efficiency? What is the formula of brake efficiency? Brake power divided by how much input, right? We are giving
Calorific value.
fuel energy. So m dot f. Now in this case, fuel energy is more, but you are getting almost same power. Why? Because fuel is getting wasted, right? So
Yes.
those things are it. So imagine now you once you start using this analysis software, you should have some references available. Okay, you are expecting this, or why you should do that particular thing. Whether simulation is giving expecting results or not. If not there, if not, why? Because don't people what people do is they just run it and they say, okay, no, I give simulation give me this value. But whether simulation is right because or wrong, if it's wrong, why it is wrong? Whether your inputs is like junk in, junk out, right? So if you put, let's say, wrong inputs, simulation is going to run it and going to give you wrong outputs. It's as an analyst software, you have to, analysis engineer, you have to understand, okay, what those relevant inputs and outputs are important. Why I'm taking time here is that, okay, I want you to have some expectation, right, from simulation. So simulation is not like a magic that, okay, you just run it and it will give you output. It's up to how you define those, how you do the modeling, how you provide those right, have you provided right inputs at right location or not? Okay. And therefore you can do this analysis. Now, as again, let me repeat now, I think first review, you don't require to show all those things. In first review, you have to show whether you have collected all the relevant inputs or not. Whether you have created wall timings, wall trend profiles, flow coefficients, air filter, CAD geometry, how you have measured those dimensions. You have measured with just manually length, diameter, or you have used some, let's say, 3D CAD model, sorry, scanner, etc. Whatever is available at your college end, okay, make use of that. And then, as I mentioned, this is going to be your reference. Okay, so now next year when the new students will come, they will have the readily available all those geometrical inputs, etc. And then maybe they can focus more on the advanced combustion, right? They can focus on maybe predictive combustion. They can focus on the emission side. They can focus on the transient side. All those things. So it's like a first year. You need to put all those efforts to create that base for the new students. Understood? Any questions till now? And then as I mentioned, if you go to the plots, you can just plot it. You can see that, okay, how the insert in the pressure is moving. And then if you go to the intake and exhaust wall, right? How is the mass flow rate? How is the intake mass flow rate, etc. Or let me go back here and create some more. Okay, so you can just add plots in individual templates. You go to individual templates will have those plots section and you can just activate whichever. Now just at this time being, I'm just adding everything, but no need to add everything every time. Okay, some relevant inputs are important. For time being, I'm just adding everything and let me run it. Any questions or how you are finding it? You are finding it very difficult or very easy? What is your first impression? No one is talking. What happened?
Pardon, sir. Yes.
No, Yeah, I'm asking this, how you are finding it? Very easy or very difficult?
Means
Not very difficult, sir. Little bit.
not very difficult.
Okay, good. Yeah. See, you are all are engineers, right? So I don't want you to have wrong impression that, okay, this is not a CAD modeling software. So learning GUI will not take more than a week time, as I mentioned, a week or 2 week time. But what that is sufficient? No, right? Imagine now you will go to the, let's say now, interview, um, and you will say that, okay, I have learned this GT power. No one will ask you, okay, now tell me where is the file, where is the scratch pad, where is the GT post, right? They will not ask you. They will ask you, okay, can you tell me what you have done there? Let's say you'll say that, okay, I have model single cylinder engine model. I converted CNG to hydrogen. Then he'll ask this basic question, right? Can you tell me about air-fuel ratio? What are the challenges you face? How you improve using a simulation? Now, as I mentioned, in simulation, you can do everything. You can convert that to hydrogen. You can do whatever you want. You need not to worry about all that hydrogen blast and everything, which can happen in the real when you will do it. We will be doing the testing, and that's the whole idea, that in simulation you can do whatever you want to do, but whether that makes sense, whatever you are doing, you will say that, okay, I achieve 150% volumetric efficiency. Whether that is possible on a natural aspirated engine, no, right?
No.
So all those things, what you are going to highlight when you talk to, when you face the interview, and then you mention that, okay, I have done this engine analysis. Whatever you are talking should make sense, and that's the reason I want you to focus on that area as well. Koi definitely, maybe it has to be there, but once that is done, start you applying those knowledge which you have learned in your engineering. Let's say I say, or maybe your team is testing, right? Your team is testing your engine vehicle directly, and they'll face, okay, no, our temperatures goes very high at this point, so you can get those details. Okay, why it is going very high temperatures, whether it's a problem with air flow rate, and then you'll say, no, no, okay, the temperatures will definitely go higher, we have to make it lean at that particular point. Why? Because you don't have sufficient air available there. So if you want to reduce the temperature, make it rich, right? So those things you can contribute from your simulation. You can do the entire engine mapping there. You can do, let's say, our circuit analysis, right? Entire drive cycle for that, and then different lab rates, different labs, then timing for that. So you can, maybe your next phase, you can target those things, right? So now this particular thing is about the gas exchange, right? So when there's a, now there's a four-stroke cycle, right? When you say the four-stroke cycle, there's an intake and exhaust. So all that analysis we can easily do, and we can see that, okay, whether that wall timings are sufficient, or we can change. I don't know. Physically you are allowed to change, but at least in simulation you can see that, okay, I can further improve that volumetric efficiency, etc. All those things. Mhm. Okay, any question? Yeah, so this is a PV diagram, right? So this is a PV diagram, and we can see that, okay, suction, compression, expansion, and exhaust. And this is the auto principle. Now the next question could be how to convert that to a hydrogen, HCNG, etc. I think that can be a next phase we can target. But here, I assume you understood, right? What is the GT input sheet? GT input sheet, not about just putting those values, but it's like going back to the individual templates, understand what kind of inputs are required, geometrical inputs, or whether it is like, let's say now, burn rate profiles, etc., wall timing, and then you can create that input sheets, and then it will be reviewed based on how you have generated those input sheets. Okay. Great. So these are the things I want. I will not go into all those details into cylinder at this point. Let's say heat transfer, combustion. That may be a next part, right? Once you are used to with GUI part, maybe we can cover those some advanced topic related to combustion in another session.
Yes, sir.
Okay, good. Any questions from anyone? So action item, I think clear for you all. From your side, what is pending, as I mentioned, is providing me the list of interested candidates for GT introduction training. Once that is done, the next is this one GT input sheet related. From my side, I will provide you GT input sheet details and access to all those candidates. Okay. And then once your introduction and everything is done, we can set up a separate meeting focusing on the engine related queries you may face, right, while doing the modeling, etc. Good. Yeah, that's it from my side. Who is there from SA?
Yes, sir. So, teams, do you
Yuvraj,
have
yeah.
any more question which you want to ask?
I think there are, just a minute, there are some chats.
They were regarding the answers of questions which was
Okay.
like this is
Great.
the time you can interact with Hitesh sir. You have
Yeah.
And we will receive the dongle. The
You're
screenshot
from
and
Vishnu,
amigos.
right?
Yeah.
Vishnu Institute, right?
Yes, sir.
Yeah, as I mentioned, I think some legal document is pending from our US counterpart. That's what I know. So maybe Monday I will just follow up with them why it is pending for
Okay.
your college. Is there anything you need to provide some information or what? And then if let's say everything goes well on Monday, I think I think at least by Friday then you should receive. It's like a courier, right? We have to send you the courier. That's it.
Okay.
Yeah. But meantime, you can create those, as I mentioned, right? The rest of the things. You can set
Yes, sir.
PPA and all those stuff at your college.
Okay.
Yeah. Anything else? I hope this session was useful for you to know what is expected, right, from you. It's not only the GUI part, but some analysis slowly, not immediately to start with, but as you progress, right? We are expecting you to do some kind of analysis, some fruitful analysis using GT software. Okay, great. If anything is not there, Yuvraj, thanks for your time.
thank you, sir, for
Yeah.
this very interactive and insightful session. It
Mhm.
will surely help the team in seamlessly installing the software and kick off this journey with like of exploring this software. So
Correct.
thanks a lot for
Yeah.
this session, sir.
Yeah. And as I
And
mentioned, right, this is the first year, so it's like a big responsibility to everyone here, this team members, to generate the base, right? And then next team can easily get benefited out of this.
exactly, sir.
Yeah.
Okay. So looking forward for the software to be very useful to all the teams.
Yeah.
Yes, sir, for this session. So with this, we will conclude our first day of hBAJA workshop. So
Thank you, Yuvraj. Bye,
thank you.
everyone. Bye.
Thank you, sir.
Thank you,
So
sir. Thank you.
see you all tomorrow, as there are very crucial sessions lined up for tomorrow as well. So yes, we'll conclude today's workshop. Thank you for joining. Bye bye. Take care.
Thank you.
You're
Thank
up,
you.
sir.